Good morning, everyone, and welcome to the annual Busy Radon Workshop. I'm Manby Acton from the Busy Lung Foundation, and on behalf of the Lung Association or the Lung Foundation, I would like to welcome everyone and thank you for joining us. And before I turn it over to Anne Marie, I would like to acknowledge that we are broadcasting from the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. So we have a very packed schedule for this morning, and I would like to turn it over right away to Anne Marie, who will be moderating this workshop. Anne Marie.
Good morning. Thanks very much, Men. And thanks to everybody who's joined us. We do have a significant number of people who have registered for this event, and I expect over the next few minutes, people will be trickling in online. I am almost always also calling in from the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh peoples here in East Vancouver. Our workshop this year is Radon in a Changing Climate, and we are really interested in how factors both environmentally, so Earth-related, may impact radon levels over time, and there's new evidence that radon levels can shift naturally year to year. So we're going to learn a little bit more about some of those processes. We're also going to understand how our built environment and our drive to decarbonize our housing stock may be leading to changes that are also increasing radon exposure. We're also going to hear a bit more about radon in the north from some of our Health Canada scientists. And a really fascinating conversation about radon and radon progeny, also known as radon daughters. Yeah, I think you're going to learn a lot. So the session today will be the scientists speaking this morning, representation from the BC Real Estate Agency, and then we'll have an open update on all the different things that are happening in BC by the BC Cancer Agency, SFU's research, some of BC Lung's work, and then we're going to have an open session. So between 11:30 and 12 will be a great time to ask follow-up questions, meet other people if you like, exchange information, because we know that this workshop really brings together people from different facets of the radon world. We have scientists, researchers, students, policymakers, realtors, building officials, people for whom radon is part of their job, but they don't necessarily always meet people who work in the other areas of radon. And I think for me, this is why it's my favorite workshop every year, is because we have such an amazing diversity of folks. And so just on that note, if you'd like to ask a question, there's two different ways to ask questions during this session we're having today. You can put a public question in the chat, or you can add to the Q&A. That's a more private way of asking a question. You can have your question answered privately, or someone can address it verbally in after they're speaking. So speakers hopefully will use their 20 minutes of time, and then we will have 5 minutes afterwards. We will have to make a limit to the number of questions that we can have for each person. But then at the end, we'll have this open session where you'll have more of an opportunity to further ask your questions. And we could even create breakout rooms if there are people who are wanting to really talk about one issue in particular. Okay, so I think we do have lots of people. Oh, is there a way to put the agenda in the chat? I'm going to hand that back over to the BC Lung folks. Is there a way to put an agenda in the chat? Can we get a certificate of attendance? I'm also going to pass that back to Men and Noah. I don't see why not, but that sounds like a great idea. So
yes, we can do that.
Okay, great.
And
okay, well, I'm going to jump right into it then. If there's any other sort of administrative questions, please put those in the chat, because you might not be the only person. For example, if you can't hear or see, then please go ahead. And maybe before we begin, I'll say who I am in case you don't know me. My name is Anne Marie. I am an associate professor in the Faculty of Health Sciences at SFU. I'm also part of the BC Lung Foundation's Healthy Indoor Environments team and the National Take Action on Radon program, where we do community engaged testing along with many other things. So I've been working in radon over 10 years now, and it continues to be a real passion for me. Sound is excellent. Great. Okay, well, without much further ado, I'm going to introduce Dr. Kathy Ryan, who's a professor at the University of Calgary in the Department of Earth, Energy, and the Environment. I saw Kathy speak maybe about 6 months ago, and I was just captivated by her information that she had to talk about and the relationship that happens deep underground as the Earth changes and how it may be impacting radon gas levels. So Kathy is trained as a hydrogeologist or a groundwater scientist and has been working with the Evict Radon National Study Team now for several years, trying to understand natural subsurface or what's known as geogenic sources that contribute to the radon levels that we see in indoor air. Okay, Dr. Ryan, I'm going to turn it over to you.
Thanks so much, Anne-Marie, for that introduction. And thanks, BC Lung, for the opportunity to talk about what I call in my research world my passion project, partly because it's a super interesting puzzle and partly because it has such significant implications for understanding sources of radon in indoor air, which everybody here knows is super important. And so thanks for pointing out that geogenic just means natural. And by deep, I mean kilometers to tens of kilometers deep in the subsurface. So that's the question I'm asking. And I'll walk you through how I got to where I am today in trying to solve this puzzle. So I have been studying what we call groundwater gas or bubbles in groundwater below the water table for some time. And really, I started in denitrification or getting rid of nitrate by a natural process, which produces N2 bubbles. And then I moved to understanding what triggers a geyser eruption. So this was work that was one of the first pieces of work to say that geysers don't erupt just because of steam or boiling, but really because these bubbles come up along these pathways, in this case, the geyser neck, and below that, fractures in the rocks. And as they rise, they get bigger, and that decreases water pressure below them, and that causes the eruption. And then in Alberta, which has hundreds of thousands of oil and gas wells, there is kind of an under the radar issue, which is what we call fugitive or unintended methane gas migration. And the methane gas migration is actually outside the well casing. It's not inside the well, it's not coming up inside, so it can't be produced. And so I started looking at methane gas migration around the outside of wells with a team of wonderful early career researchers. And then Aaron Godarzi, who is the heart and soul of Evict Radon National Study, he gave me a cold call, which means that he called me up and said, "Hi, I'm Aaron, and I understand that you are interested in groundwater gases." And so this is what I remember of that conversation, which was now 3 or 4 years ago. What did I know about subsurface radon sources? And to be frank, what I knew about it is probably what I studied in the 80s as an undergraduate geological engineer. And the question that he asked is, when we look at the geographical distribution of radon in homes, we know that part of it is because of what they call the building architecture, or whether you have, it's how many stories you have, how big your house footprint is, whether you have new windows or old windows, et cetera, et cetera. But still, there's a lot of unpredictability or heterogeneity in homes that have high radon and low radon. And could it be from the subsurface sources? And before I go further, I want to say that pretty much everybody, there's some radon produced in building materials, but that's been studied and ameliorated or mitigated. Pretty much everybody agrees that radon, it comes from the subsurface. And the working understanding is that it either comes from shallow soils or shallow sediment, unconsolidated sediments like glacial sediments, or it comes from near surface or shallow bedrock. And that's what we're wondering if that's entirely the case. And so because people think it comes from shallow soils or shallow sediment, a lot of effort, probably hundreds of papers are out there that have looked at the distribution of radon in indoor air. So that would be the test that you do in your basement and you send into BC Lung. They've looked at where they have high radon and low radon, and they've compared the distribution geographically with the bedrock geology and the superficial geology. And the last time I gave this talk, I just looked for a recent article of this nature. So they're looking at the natural radon potential based on geology. And here's what they found. They found that bedrock geology explained 10% of the distribution, superficial geology explained 4%, soil gas radon explained 10%, and whether or not the soils were permeable explained 4%. So that's not very satisfactory. And the overwhelming majority of papers that do this kind of work come to the conclusion they don't come to a good correlation between the distribution of radon in basements or homes and the geology. So that plays into a source that's not specifically related to the geology and where radon comes from in the subsurface. So the first thing, to be honest, the first thing that I thought, which completely turned out to be not true, is that radon was coming out of the subsurface in groundwater, pumped out of wells. And that one thing that people don't look at when they sample well water or groundwater for anything is what's in the bubbles that sometimes come up. So if you live in a house that has pipes that knock or that produces a glass of water that's milky white because there's little micro bubbles in it, then you probably have naturally gassy groundwater. And people don't measure that gas when they measure constituents in groundwater. And so I thought that was true of radon, and probably we were underestimating how much radon was coming out of water wells. So before I go any further, I really want to reassure everybody who's on a water well that we did not find that that's true. But I want to walk you through this because we found some provocative fun information that had us looking more in more detail. And so we split the Evict Radon National Study at that time, 20,000 indoor air measurements between homes that were supplied by surface water. So that's rivers and lakes, mostly rivers in Alberta. And that's all of the cities and most of the towns and villages. And then we had rural homes, which almost always have water wells, private water wells for water supply. I shouldn't say almost always, because in irrigation districts, many home owners use irrigation water. And then into people that relied on municipal water wells, which includes Jasper, Banff, Canmore, etc. And so we called the data, and what we found is that people who rely on domestic water wells have a significantly higher concentration of radon in their homes, in their indoor air, than people who rely on surface water, and that municipal wells are somewhere in between. And so if you use a water well for your water supply, then the chances are that you have a higher concentration than somebody who uses surface water. And so then we went down the road of measuring radon in water wells and considering the radon that was in any bubbles that came out. And that came up with unsatisfactory results. So we concluded that the radon that is in the water well, the well water coming out of the well, was not a good source, was not a significant source of radon in indoor air. And so I want to reemphasize that if you rely on a groundwater well, that's very likely not a significant source of radon. But still, there's this correlation between homes that have water wells and higher indoor radon. And so that set us thinking a little bit more about it. And now I only have one display here, so I beg your pardon. This is the work that Evangeline Eldridge did, understanding that radon was not a significant source of groundwater. Here's a lovely schematic that shows how radon comes up out of different places into the basement, including in this schematic, they have well water. And this is a concentration of radon in groundwater in becquerels per liter. So 0.2 becquerels per liter would be the indoor air concentration, not a great, not a great way to convert there. And this is the methane that's in the groundwater. So you have high methane, you have low radon, you have high radon, you have low methane. And this is the total dissolved gas pressure that would produce bubbles. You have high total dissolved gas pressure, you have low radon, and low total dissolved gas pressure, you have high radon. And so this suggests that bubbles aren't a significant source in the dissolved radon that we measure, which these concentrations are not high enough to produce significant radon in indoor air. So we discount the water being pumped into the home as a significant source of radon in indoor air. And then I had another really interesting communication from the Evict Radon National Study, which was that there was a radon mitigator in Calgary who had a home with super high, and he tells me the highest radon in indoor air that he has measured anywhere and he has seen reported anywhere. And not only did this home have high radon in indoor air, but they also had a water well in the basement. So you might think that that's unusual to have a water well in the basement, but in fact, it happens when people have their water well close to their house and then they expand the footprint of their home. And it's convenient just to keep the water well in the basement rather than drill a new one. So I've seen it, a handful of times. It's not that unusual. And then I was having a conversation with the homeowner, and he said, well, we've got the water well in this little room, and every so often it howls, the room howls. So there's something to that groundwater scientists know about, and that is that this would be what we call a breathing well. So here's a well, and it goes down into the subsurface. This is the water. This is the soil zone here. This is the unconsolidated zone. And here's the well screen. So that's just a tube that has holes in it. So when the pump is put down, it pumps water through those holes and up into the home. And this would be the water table. And so in some wells, the screen is above the water table, which is not great, but sometimes the water table falls with time. And in other wells, this casing or this tube in the shallow part would have holes in it, either because it corroded or because they connected two different pipes and they didn't seal the connections well, etc. So a breathing well basically has connection with the unsaturated zone or the bedrock or soil above the water table inside the well. And so when the air pressure goes down, it causes the soil water to go into the well and come up through the well. And when the air pressure goes up, it pushes the soil water down into the well. And basically what this does is gives us an opportunity to measure the gases in deeper soil water or deeper unconsolidated zone water. And so we did an extensive monitoring 11-day monitoring system, 11-day monitoring program on this house. And we measured radon every day, every hour. And you can't see this, and I don't want to go into it in too detail, but we got up to 80,000 becquerels per cubic meter compared to a Health Canada indoor air standard of 200. So super high radon concentrations, only when the air pressure was decreasing. So it was a breathing well. And when the air pressure was decreasing and the well was breathing out, then it was putting out gas that had high radon. And we took some gas samples, some grab samples, and analyzed them for carbon dioxide. And it also had carbon dioxide that was proportional to the radon, so correlated with the radon. So these deep gases also have high carbon dioxide when they have high radon. And high carbon dioxide, high radon comes out of the deep subsurface. It comes out in volcanoes. It comes out in deep faults. It's in caves. It's in mine shafts. And when researchers measure CO2 and radon, they are correlated. And then probably the most interesting thing is that we measured isotopes of noble gases, and these isotopes suggest a quite deep component. So there's two kinds of isotopes. One is neon, and it suggests radon that comes from the mantle, which is the molten center of the Earth, which is so deep it even hurts my head to suggest that that's the case. And the other isotope suggested a crustal component. So probably this gas is a mixture, probably with some gases that are super deep, some gases that are pretty deep, and some gases that are soil gases. So now we revise this conceptual model of this home with radon coming in, not just from the soil zone, but maybe from this gas migration outside the well casing, not in the groundwater so much, not in the well water so much, but coming up outside the well casing. And that is consistent with fugitive methane gas migration that happens outside of oil and gas wells. So the same process, which is that there's a pathway here between the grouting of the casing and where the drill rig drilled down, which is a good pathway for gases, bubbles in the subsurface that operate under buoyancy. So they want to rise along these pathways to make it to the near subsurface. And then once they pass the water table, the buoyancy is gone, and then they travel just under diffusion. So the working hypothesis that we're trying to get more puzzle pieces to is that where these pathways exit the water table are significant sources of high radon concentration, particularly during low pressure events when gases move up from the subsurface. And then Evict Radon National Study put together an even bigger set of data that looked at all of the different components that are associated with radon in indoor air. This is the Evangeline study, which has the radon and groundwater concentrations. And I want to look in a little bit more detail at this lower right-hand graph here. This is available online if you search KHAN, K-H-A-N, Pearson and Rural Communities Radon. You can find a full copy of it. And so here we split the indoor air radon concentration between wells that have homes with indoor air concentrations that have really nearby wells, so that's the blue data, or homes that have really dense wells that are within 1,600 meters of residential properties, which happens to be a mile, because often the wells are only located within a section in the database, which is a mile by a mile. And so in particular, the wells that have the homes that have a high density of water wells around them, you can see that the higher the nearer the wells and the higher the density, the higher the indoor radon concentration. So that kind of confirms the earlier data that I showed you, which is that if you have wells that are close to you and dense, that you have on average higher radon concentrations. So our working conceptual model is that the free phase gases, so probably mostly carbon dioxide with radon, maybe the radon comes from the same source as the carbon dioxide, maybe it partitions or hitchhikes onto the carbon dioxide bubble as it's coming up, and they go upwards along faults or through permeable formations under buoyancy, always wanting to float upwards in the saturated zone, until they reach a restrictive layer. So this is a low permeability layer that doesn't have any cracks in it or windows. And so then the carbon dioxide radon mixture would pool under this layer. And then if you punch a well through that, even if you seal the outside of the well, that provides a conduit, because it's really hard to seal these wells. Heaven knows the oil and gas industry has tried all kinds of cement mixtures, all kinds of placement methods to prevent the fugitive gas migration outside the well casing with limited success. So then if there is this free phase gas pocket within the depth of the water well, the bubbles would come up outside the well and form this source or form this pathway for radon to get to the near surface at discrete locations that aren't easily considered or predictable. And the thing about radon that probably most of you know, but I'll reiterate here, is that it's got this short half-life of 3.8 days. So if radon has to be held up in this gas pocket here, then it has more opportunity to decay. It's not that this gas pocket the gases here won't make it to the surface. Eventually they will, but the longer it takes, the more radon decay there is and the lower the radon concentrations are. And just as an aside, we also looked at energy wells in a preliminary sense. And we also found here that there's, probably 400,000 to 600,000 energy wells in the province. And this is the mean radon concentration, radon in indoor air. And again, when we had high density wells, we had higher radon concentrations. And the proximity wasn't as much of a factor, partly because domestic water wells are intentionally located close to homes and energy wells are not. So our active research question here is whether or not the transport of deep three-phase gases or gas bubbles along fracture pathways, well bores, etc., are a significant source of radon in the subsurface. And certainly this has been looked at historically, and there is, so some researchers call these geogases, and there are cold seeps of CO2 and methane coming out all over the earth. And so then the question that we are asking is whether or not a well provides an additional pathway here. And radon has a really super interesting history in geoscience, in that it's known as a precursor to earthquakes. So people have looked at it, and they've looked at it across faults here, faults as well. So this is a geologic fault. That means that these beds on the left-hand side moved upwards relative to these beds on the right-hand side. And these researchers measured radon and found it highest over the fault. And they also measured CO2 and found some correlation. So the question that I bring to the Evict Radon National Study table frequently is, are we looking at the right geographic or geologic approach to interpreting our radon concentrations? So they just put out the 10-year study, the Evict Radon, the national report card on radon, I think, and they split the country into kind of, I don't know what you call these, political jurisdictions, and showed these big picture concentrations. And, one step better, I think, would be to look at the big picture geology of the country and split them that way. And I think that one step even better that I would love to see us get to is that we look at the major geologic boundaries. So there's one that cuts Nova Scotia in half. There is one that is the Columbia River Valley. And then there's several of them in the fascinating geologic territory of British Columbia that I was actually just out last week with an undergraduate student from UBC Okanagan sampling springs as deep sources to see if we could add more detail to this puzzle that we're working on. So this is what I hope you take home from this presentation. On average, rural homes that have water wells have higher radon in Alberta, and it's not in the well water supply. It could be related to geogases coming up along the well. And so you have an increased incentive to test, in my humble opinion. And everybody wants a map of radon potential in order to know whether or not they test. But the truth is that there's so much heterogeneity in these measurements that there aren't, in my view, there's no good evidence that there's a couple of papers internationally with super clear boundaries that do show geographic variation. But I have not seen that in the data that I've looked at with the Vic Radon National Study. You can have side-by-side homes with really, really different radon concentrations. And so don't rely on being in a rural area or being close to a geologic fault or being on the Canadian Shield to give you information about whether or not you should test. I think that everybody should test. And I hope you'll follow along as we continue to work away at this puzzle as to whether or not deep bubbles are a source of radon in indoor air. You can see that we've had a couple of failed hypotheses so far, and that's the way research goes, and it's all a fun process. So in addition to thanking you for this opportunity to talk to you about my passion project, I have to thank all of the people that I get to work with in the wonderful world of research, and especially the early career researchers who do all the heavy lifting. So thank you.
Thank you very much, Kathy. That was fascinating. I do have time for one question, and I think you may have answered it during the session, but I'm going to repeat it again. So does fracking increase radon levels as well? I'm going to I'm wondering if that person meant, does it increase the radon levels indoors homes? But I'm just going to turn that back over to you.
Yeah, that's a good question. And the public concern over fracking over the last decades has done a great service to the recognition of fugitive methane migration outside of energy wells. So obviously I'm an Albertan groundwater scientist. I followed very closely the literature and the evidence, and there's not good evidence from a groundwater quality perspective that fracking is a concern. It did identify fugitive methane migration around the outside of energy wells. So radon, there's this provocative evidence that radon is a precursor of earthquakes, and that's because when the earth moves, when there's bubbles underground, it kind of jiggles them and they come up. So it's possible, and I'm saying possible because I have seen zero evidence. It's possible that when they frack, I understand that in shallow fracks you can sometimes feel them at surface, and homes are sometimes get damaged. And so when you jiggle the earth like that, there could be one event in which radon comes out. That would be a higher event, and it would mitigate radon coming up later on, probably. So short-term generation of high radon possible, but it would then be followed by lower radon because there's probably a constant source at some unimaginable depth.
Okay, I have one other question. So are you suggesting that people with water wells or agricultural wells, I guess that's a farm well, there's even more reason to test your home because that could be contributing to radon indoors?
So statistically, if you have a water well, there's a higher average concentration. So statistically, you're likely to have a higher indoor radon and indoor air concentration. So you should test. That's not to say that if you live in the city that you shouldn't test. I think personally, I feel very strongly based on the evidence that I've seen that everybody should test. Every time one of my kids goes into a new house, I buy a test and send it to their house.
Great. Well, there's lots of people on the line here who are from more rural regions with a higher concentration of water wells. So I think this has been a fascinating. And also, do you mind? So there's lots of very technical questions. Would you mind putting your email in the chat for people to follow up? Because I think that you could probably address those better with a more fulsome conversation, including things like having concrete basements. So I appreciate everyone writing in the questions. There probably will be more. So Dr. Ryan can look at the chat after this if you have more technical or specific questions. Okay, well, thank you so much. That was fascinating. And yeah, I think there's so much more to radon that we just don't know. So that's why your presentation really piqued my interest, because it's like, wow, radon levels may change over time. So I know that there's an increased interest in repeated measures. So maybe every 5 years, people should be testing their homes. Do you have any last comment about that?
Oh, I haven't seen good evidence, Anne Marie. I'm such a scientist. I'd have to look at the data first. Can I
Okay,
put it on the docket for next time?
let's put it on the docket for next time. Okay, thank you. Thank you very much.
Thanks, everyone.
I believe Dr. Ryan may be joining us later on today in the Q&A session that we have between 11:30 and 12. So we're shifting gears now, and we're going to hear from Colin Dumais, who many of you may know, who's the owner and operator of Radon West in Alberta, although he does also do work across our border into British Columbia. And he's been really involved in the development of Canadian-specific radon curriculum. He teaches people how to test and mitigate homes. And he serves on many committees for Health Canada and the Canadian National Radon Program. And he and the team have collaborated to develop educational programs actually for here and in the United States. So I know we have people from the US, so you may know Colin from elsewhere. And he's going to give us a fascinating talk today, which I think in BC, as we're a community that or communities that are more and more impacted by particulate matter and fire smoke. So again, in our changing environment, what might this mean for our radon exposure when we have radon and things like particulate matter in our indoor environment? So I'm going to hand it over to Colin. Are you here? I know that you're in a different province than you usually are, Colin. So can we hear you? Can you hear
Yeah,
us?
yeah, I can hear you. Can you hear me?
We can hear you.
Oh,
Okay.
awesome. I don't know if I
Excellent.
think I
Thank
have
you
my
very much,
camera on.
Colin.
No
Thank you.
problem. No problem. Thank you very much, Anne Marie. We're going to talk about radon's little helpers, how fine particles amp up our exposure. A lot of people aren't aware that actually radon has some helpers, and we're gonna talk about this. I'm going to get Noah to advance my slides, and as we go along, just because I'm on site, if you hear any construction, I'm currently in Hamilton training a new group of mitigators, and they're drilling, hopefully safely downstairs and working away. And I just took a small break here to be with you guys. Okay, next slide. Okay, what you might be surprising to you is a radon gas is not that bad for you. Now, I want to premise this by saying that there is risk from radon. We talk about risk from radon. We talk about deaths and cancers from radon. That's all true. But actually, only 5% of the risk from radon is from radon in the gaseous phase. So radon is like this adorable but semi-ferocious puppy with his teeth bared. Okay, next slide. Meanwhile, the radon decay products, primarily polonium-218 and 214, are the big snarling Dobermans that can kill you. Okay, so this is the thing. Radon gas, you can breathe it in and you can breathe it out in many cases with no decays. But when you breathe in radon decay products, primarily the polonium series, which are generally stuck to pieces of dust that you inhale, they get deposited into your airways. They are still alpha emitters, and we get more alpha energies from the decay of those guys than we do from the radon gas. So technically, 95% of all of the health risks from radon exposure actually come from exposure to the radon decay products. So we're going to talk a little bit more about that. Okay, next slide. So if radon is not that dangerous, right, why do we measure radon? Why do we talk about radon? Well, if radon is a Lego block, radon decay products is a pile of watch gears. Much more complicated to measure, expensive to measure, and more difficult to sort of understand. So radon is a useful abstraction for the actual risk from the overall presence of radon gas in our environment. Okay, next slide. So I don't know if I can hear drilling through my headphones. I don't know if you can hear it. It won't take too long. This is the real world. We're doing real work out here. Okay, so what units do we use for RDP measurements? If we measure radon in becquerels per cubic meter, we're generally pretty familiar with that. And of course, we are not measuring radon. We are measuring the decay of radon. That's the becquerel part, is 1 decay per second. So we're actually measuring the decay of radon gas. We are not measuring the concentration of radon. We would be measuring in units that are not parts per million, parts per billion, parts per trillion. It would be much, much, much less than that. So instead, we measure in a unit called becquerels per cubic meter, the decay of radon. And the reason for that is really simple. Radon is a noble gas. We really can't detect it any other way. There's no instruments that can actually detect radon gas. So it's the analogy to me is like a shooting star. When you look up in the sky and you see a shooting star, you could see it and you could count it very easily. But did you know that many of these shooting stars are the size of a grain of sand? If that grain of sand did not light up so brightly and burn up in the atmosphere, we wouldn't even know it was there, it'd be too small. Radon, measuring radon is kind of like that. The gas is not detectable. It's in concentrations that are too small. We can't measure it. So we measure the decay of radon because the decay is a high energy burst where an alpha particle shoots out. We can see that. Instrumentation can detect that energy. For radon decay products, we use a measurement called working levels. That's been historically used for radon decay product measurements. In metric, I think we would measure it in joules per cubic meter. So we have a totally different measuring system for RDPs versus radon. Okay, next slide. Now, in fact, radon action levels, the 200 becquerels we per cubic meter we use in Canada, they're actually reverse engineered from working level measurements. So, and that makes sense. If I'm saying the radon decay products are the dangerous part and they're measured in working levels, then of course the radon levels should be abstracted from these working level measurements. And in fact, they are. So 0.02 working levels is our sort of our action level for radon decay product measurements. And that translates to about 200 becquerels per cubic meter. In other words, radon action levels are a practical abstraction of working level exposure guidelines. And maybe many of you have wondered, and I've heard many times from my customers, why do the Americans use 148 becquerels per cubic meter? That's a strange measurement, right? And it's an interesting concept because, in fact, the American action level is also derived from 0.02 working levels. The difference is the Americans assumed a different fraction of radon decay products floating in the air. They assumed 50% of the radon decay products that are formed are stuck to dust in the air. They're available to be inhaled and breathed in. And in Canada, we assumed 40%. And that accounts for the difference between the action level of 148 and 200 between the US and Canada. Okay, next slide. All right. Now, radon decay products, they could be, when they're formed, initially, of course, it's polonium-218, and then it goes on through a series of other decays. They could be attached to an airborne dust particle, which they like to do. They may be unattached and just on their own. They could be plated out and stuck to a wall or a surface, or they, of course, they could be ventilated out of that environment. One thing I want to point out, this is the world's first, you guys seeing the world's first stereoscopic, high resolution electron imagery of radon decay products in their actual environments. Absolutely. So these guys are some combination of all these things. We can influence the percentage that get attached, the percentage that are unattached, the percentage that are ventilated out, or the ones that are plated out. And that's what we're going to talk about because, of course, if you're plated out or ventilated out, we can't inhale those. Those are fine. They're so-called safe. Okay, next slide. Now, according to the IRCP, this is publication 137, just a very simple block kind of chart I took out of this document that shows that when radon comes into a building or your home or a room, it will decay and either remain unattached. It may deposit on a surface. It could be ventilated out. It may attach itself to a dust particle primarily, which in itself may be ventilated out or could be deposited on a surface. When we get a further decay, that dust particle may dislodge and it may become unattached again. And of course, then either deposited, ventilated, or attached. So this is happening all the time. This dance is happening all the time. And the only radon that we can actually inhale will be the ones that are attached or unattached and just floating around in our environment. Those are the ones we want to worry about. If they're deposited or ventilated out, no problem. Okay, next slide. Now we measure, I told you the unit was working levels, so it may not surprise you that the type of instrument that measures radon decay products is called a working level monitor. And it's the reason why we don't measure working levels to some extent is because it's complicated. A radon detector is very simple, inexpensive, easy to use. Radon diffuses into the chamber. Radon decays are detected and displayed on a screen. It's very straightforward, but not radon decay products. They are generally stuck to pieces of dust, or they are atoms that are floating around in the air, and they don't like to diffuse into the same kind of chamber like a radon gas would. So instead, there's an instrument with a small pump. It pulls air through a filter. The radon decay products, which are generally attached to pieces of dust, get trapped on that filter. And then we can measure the radiation given off by the dust that's trapped on the filter. So you can already see it's a very impractical device to use for homeowners. You have to remove and change the filters quite often. The instrumentation is active. There's a pump, so it has to be powered not by batteries, of course, but by mains electricity. So working level monitors cost many thousands of dollars, and radon monitors cost hundreds of dollars. And you can see on the right-hand side, this is what the radon decay working level monitor is able to detect. It can detect the alpha emissions, of course, from radon that's in the air, which is generally why we would also measure radon with a separate device so we can subtract that measurement. And so we're left with only radon decay products, because the working level monitor will also measure polonium-218 and polonium-214 primarily. And those are the bad guys. Okay, next one. Now, unattached RDPs, they're more likely to be plated out and removed from our breathing zone. They're very sticky. They love to stick to stuff. So unattached RDPs stick to stuff. Now, there's a lot of research that says, well, perhaps the unattached ones are the most dangerous ones. They can maybe go deeper in your lungs or cause more damage. There's still some evolving science on that. But the unattached ones generally are very sticky and want to stick to stuff. And that is part of the problem, really. Okay, next slide. Right. So a lot of these RDPs will plate out. Again, another first, we didn't realize that radon decay products had two little dangly legs. We never saw that coming. So this is the first image of its kind. So radon decay products that are plated out, they're not measured by the working level monitor because they're not breathable. The pump cannot suck them up and draw them through the filter. So radon decay products that are plated out are harmless. And so plating them out is what we would like to see, of course. And to some extent, we have some control over that. So let's take a look at this next slide. And the question is, can you have elevated radon and low health risk? Is that possible? Can we actually have radons above 200 becquerels per cubic meter and yet still have a relatively low health risk? Well, the answer is yes, we can actually. What if we filtered out? What if we filtered out the air and we filtered out all the dust particles that are holding on to radon decay products that we otherwise would be floating around and we might breathe in and inhale? So filtering the air is very effective at removing radon decay products, but it will not remove radon. So the radon levels would be the same. What if we circulate the air? That sounds like it wouldn't have any effect, but in fact it does. Circulating the air draws this air that contains dust particles with radon decay products attached across and near objects in our walls and surfaces like walls and ceilings and objects that may be attracted to those radon decay products, and it sticks and they plate out. So circulating the air actually has a great impact on the concentration of radon decay products in our environment. And of course, ventilation, which would reduce radon as well, basically exchanging this high radon decay product indoor air with outdoor air is always going to be beneficial for our health risk. Okay, so next slide, and let's look at the other side of this. Can we have low radon and high health risk? That's a more scary one, but the answer is yes, you can. If a building or a room or a house has very low ventilation, radon decay products tend to stay in the air. Have you ever been in a stale, stagnant room and you look and the sun is beaming in through the windows and all those little dust bunnies are floating around? Well, those dust bunnies, they're quite large. They're probably PM10 and larger. They're not the ones we're really talking about, but you just get the sense that stale, stagnant air has more particles floating around in it. And that would be correct. That would be correct. Increasing particulate matter, of course, could give more attachment sites for radon decay products to attach to, and therefore be floating around and ready to be inhaled. Um, breathing more. If you're exercising and you're inhaling twice the rate that you normally would, you're getting essentially twice the exposure at any given level of radon or radon decay products. So it is possible to have low radon, high health risk. Luckily, many studies have shown that on average, homes have about a 40% ratio of radon decay products to radon, and it is sensitive to ventilation, stagnation, particulate counts, but it's fairly good. Next slide. But what about wildfire smoke? Wildfires are becoming more and more prevalent. I don't think I have to tell anybody that. In my home, I can only remember one time as a child where I saw haze from wildfire smoke in the distance. And now it's like, is July ruined, or July and August, or July, August, September? So we've got a lot more wildfires and wildfire smoke in our environments than we've had before. And wildfire smoke may affect our exposure to radon radiation. Okay, next slide. Now, some of the guidance, I'm not picking on Alberta long, but a lot of the guidance that you'll find online when we have wildfire smoke and a lot of particulate matter in the air is to stay indoors and keep the doors, windows, and everything shut, right? And turn everything on recirculation and close off fresh outdoor air so we don't bring any wildfire smoke. Well, we've already seen what that's going to do. That's going to increase our exposure to the radon decay products that are floating around. Okay, next slide. So increasing particulate matter is going to reduce the unattached fraction. It's going to reduce plate out. It's going to increase our potential exposure by increasing the amount of breathable RDPs that are floating around and ready to be inhaled. All right, next slide. Now, luckily, I guess for us radon geeks out there, this provides fertile ground for further research, of course. So that is interesting to all of us. And I'm going to present a little bit of research here from Kim Waldron from Colorado, a friend of mine. She's been doing a little bit of research on this. Let's take a look at what we've got in the next slide. So on this slide on the left in red, we see the activity of the radon decay products, fairly constant there. And below that in blue, we see the EPA exposure for RDP exposure, 0.02 working levels. And at that point where that vertical dashed bar is, we've added some particulates in the environment is the only change we've made. We've added some PM 2.5, and you can see that green line increase as the particulate matter increases in this room. And of course, the radon decay product activity goes up as well, because now we've given more attachment points for further RDPs to remain suspended in the air and available to be breathed in. They're not being plated out, they're not being ventilated, they're now sticking to their dust buddy and hanging around in the room, and therefore our exposure to radon decay products is increasing quite a bit. Now, at that second dashed vertical line, an air filter was turned on. And right away, we see the particulate matter go down, the green line goes right back down, and so does the radon decay product activity. It also goes down. And if you notice, it went down lower than the actual EPA guidance for RDP exposure, even though we haven't changed anything. So we've actually turned this into a safe environment. Okay, next slide. This is the same concept, except I'm showing the radon gas. So you'll notice radon gas, which are these purple dots, starting on left and rising up. They reach an equilibrium there at approximately, what do we see, 40 picocuries per liter. So what is that, 1,600 becquerels per cubic meter? So fairly high level of radon gas exposure. We see the radon decay products in that clusters of red at the bottom. It increases quickly above the radon EPA guidance for radon decay product exposure. And at that first dashed line, we add some particulates again, and look what happens. The radon decay product activity goes up again, just like before. But here's the interesting thing. Look at the radon gas. Flatlined. Radon, no difference that we've added particulates in the environment. Radon gas measurements remain the same. Okay, at that second vertical dashed line, we've turned on an air cleaner again. Look what happens to the radon. Stays exactly the same, completely unaffected by the air cleaner. But look what happens to the radon decay product activity. Goes down again. In fact, goes down below the EPA exposure for radon decay products. And yet, the radon is maintained at a fairly high 1,600 becquerels per cubic meter. So the takeaway is wildfire smoke can increase our exposure. Particulate matter can increase our exposure. Stagnant air can increase our exposure to radon gas radiation beyond that which we would predict from just measuring radon gas. And I want to mention for sure that it is still best practice to fix a radon gas problem by fixing the radon gas itself and not the radon decay product activity in most cases. Because following the central and first point of any kind of contaminant control is source control. And if we can prevent radon from coming in, we can prevent the formation of radon decay products as well. So we've already taken care of radon decay products by taking care of the radon. There are some niche applications where we do want to look at radon decay product activity, and maybe that's the method for reducing exposure. But by and large, in 99.9999% of homes and 95% of businesses, we are still going to be working to reduce our exposure and the ingress of radon gas. But we want to keep the door open for radon decay products. We don't want to lose sight of the fact that these are the guys that are bad for us. These are the guys that all the action levels around the world are actually established from. Okay, last slide. That's it. I thank you for having me, and I wish you low radon decay products, and clean air. And if there's any time for questions, I'd love to take some.
Okay, we do have quite a few questions. Thank you very much for that fascinating conversation. I didn't know that radon gas was so cute and had the little legs, Colin. That's kind of
Nobody
amazing.
did. That's the thing. This is all groundbreaking right here.
Okay, so I had some people ask for some clarification. So a radon mitigation system prevents radon from coming into the home, so you have a low radiation home, versus a ventilation approach, which means that there's radiation in the air and you're constantly trying to vent it out. Is that correct?
Yeah, radon mitigation systems, the one we most often recommend to people because of the best results, is a subslab depressurization system. It draws radon from the ground. It creates a low pressure under your house, doesn't change the pressure of your house, and it prevents radon gas from entering your house to begin with. So if we prevent radon gas from entering, we have also prevented radon decay product formation. So it is generally best practice to remove radon from the ground using an active slab radon depressurization system. 100% correct. Ventilation is an approach where the contaminant of any kind of contaminant you can think of is coming into your space, and you're just trying to dilute it by bringing in fresher outdoor air to reduce the exposure of the stuff inside. And ventilation does have an approach as well, don't get me wrong, but active slab depressurization systems, the kind that a radon professional would install for your home to fix your radon problem, is still by far and away the most sensible and effective way to control your exposure to radon and radon decay products.
Okay, I think we have time for one more question. Would you support a school or workplace finding mitigation expensive to instead buy a working level monitor and then use HEPA filters or MERV 13 to be a cheaper option? I know that's a big question, but for a school or a workplace where maybe subslab depressurization isn't possible, would you buy a working level meter and then try to vent it out?
Right. Well, there's a couple of angles there. You're right. That's a very big question. We could have a whole seminar just on that question alone. You said in your question that if it wasn't possible, and then the original poster asked if it was too expensive. So possible and expensive are two different things. It's an approach that technically would satisfy OH&S, I think, in most cases. The problem again here is education. A lot of the guidelines are always talking about radon. We've gotten so used to talking about radon, that if you talk about this other approach, you may get pushback. But I think let's consider some of the drawbacks maybe to measuring and mitigating based on radon decay products. And as long as you can overcome those, it's fine. But a radon system is just so effective with a small fan. They last for a long time. Measuring radon is so trivial and easy. You can measure the radon in every classroom. It's just so simple. Working level monitors are very expensive, thousands and thousands of dollars. You need to maintain them and change these filters. You're not going to buy one for every classroom. You're going to only have one of them. If your filters stop working, if they get plugged, if they get bypassed, they get changed, you switch from a HEPA to a MERV 8, you might affect the working level measurements. So I think the challenge would be, the approach is fine, but the challenge would be, do we have enough competency and procedural integrity to make sure that we are actively making sure it's still working. That would be the challenge. Is it still working all the time? Not just once, not just for this moment in time. Is it continuing to work and protect the people in the building? That if you can prove that, sure. But that's a tough one. That's a tough row to hoe.
Right. And, I guess people who know me know that I work in the area of fire smoke, and we are seeing significant amounts of particulates coming into homes. So there's lots of technical questions here. Do you mind, Colin, if we put your email in the chat so that people can ask you these more directly?
No, no problem at all. I got a chat here. Let's see if I can send one to everyone. This is hosts and panelists. There's everyone.
Yeah, there's lots of
Here we
questions
go.
about ASDS, filters, P100 half masks, and attached radon decay products. So I think maybe we should take these offline. But I thought your presentation was so provocative because it really shows that keeping radon out of the house then reduces the likelihood that those very dangerous progeny or decay products attach to smoke, and then you're continually inhaling radiation even and above more of what you had before. So I think for me, your presentation really pointed to the importance of having a subslab depressurization system if radon is an issue in your home, because that seems to be the most health protective approach.
100%. That's absolutely true. However, this is just technology. What if someone invents a working level monitor that costs as little as a radon monitor and is user friendly and easy? Now we'd be having a completely different situation. So it's really the technology at the moment that is having us focus on radon, which makes a lot of sense.
It
Yes.
does.
And according to the US Nuclear Safety Commission, a half mass P100 respirator reduces our exposure to airborne radionuclides by a factor of 10, as an assigned protection factor of 10. So further evidence that if we go into a high radon environment, I talk to my students about this, we have a half mask respirator fitted with P100 cartridges, we can reduce our exposure to the airborne radionuclides by a factor of 10. So it's proof that it works.
Excellent. Okay, I'm gonna thank you very much. You maybe can address some of these questions on or leave it if you have to go back to teaching your students. But thank you so much for sharing your fantastic presentation and that lovely glimpse to the inner life of the radon gas particle.
Yes, thank you for that one. Please email me if you guys want. I've got to get back to my students. They're mulling around. I'm not sure what they're up to, so I better keep them under control here. Send your messages in the email. Thank you.
Thank you.
Okay, bye-bye.
Bye-bye. Okay, next up we have Mathieu Broussard. I want everyone to big a stretch, though. If we were here, the Saskatchewan lung people were here, they would be doing some cardio fitness and other things. I think you have to stop sharing your screen, or Noah. Yeah, there we go. So many of you have probably met Mathieu before. He is a regional specialist in radiation for Health Canada, and he has held that degree since 2008. He has a master's degree in biochemistry, and he conducts research on a wide range of different things, including radioisotopes and radiation safety. And he's been involved in the measurement of radon in federal buildings. So the federal government has measured almost all of the buildings or all the buildings it's responsible for. And Mathieu is also part of the mitigation guides for professionals and homeowners. So if you've ever seen those guides they're publicly available. Mathieu has been a big part of that. And also standards, and he gives lectures and interviews on radon. He is also our sort of key bilingual person. So if you're a French speaking person, please feel free to put questions in French in the chat as well. And we've asked him here today to talk about radon and energy retrofit. So again, thinking about radon in a changing environment, what we're doing in Canada is really trying to ensure people have more energy efficient homes to deal with climate change, but those might have some serious implications for radon as well. So I'm going to turn it over to you, Mathieu. Take it away, please.
Oh, first, thank you for the introduction, Dr. Nicole. Thank you to BC Lung for organizing such interesting events. We have only 20 minutes to talk of a very important topic, which is likely be touching or had already touched every one of us. And we're talking about energy retrofits because we will have in the near future to increase the efficiency of our dwelling in terms of energy consumption. and it's likely to have impact on radon. Because what's fine as a radon concentration in a bit indoor air is an equilibrium from radon entering from the entry routes, so the cracks, the joints, and the radon exfiltering, so through ventilation and air renewal. Um, in the recent years, the energy retrofit subsidized programs became a realities across Canada and in many countries as well. So this is not just a Canadian reality to make or building more efficient, but usually making a building more energy efficient mean reducing the air leakage, so reducing the air renewal. Unfortunately, international researcher shows a radon increase associated to energy retrofit program. By energy retrofit, we're meaning taking an existing home and improving its energy. So by sealing it increasing the insulation or changing the heating system. Our neighbors in the south, the US EPA, they are giving some advice to protect yourself by testing radon in the air after completing an energy retrofit. Just to give you a number, as yesterday, they were in Canada. The Greener Home Grant is close to 400, more than 450,000 people will have benefit from the Greener Home Grant. And most or several province and municipal regulator are also subsidizing or co-subsidizing. So this is coming in our life. Right now, they are subsidized or volunteer approach, but in the near future, we will have, I understand it will become mandatory that we will have to increase to reduce the energy consumption of our home, or it will be taxes. So of course, Health Canada will encourage all discussion to reconcile energy efficiency and radon prevention. This slide is too small to read, but it's just a meta-analysis. We registered 11 studies that monitored the radon after an energy retrofit program, and 9 out of 10 studied shown certain level of increase. We published last year a pamphlet on so an information document on radon and energy retrofit. So to inform the public, to inform the regulator on the issue. It's not a surprise. The air leakage, so the ACH 50 is an indicator of the air leakage of a building. It's made with a blower door at 50 pascals. So in all provinces in Canada over the years, we saw, and this is a very old graph. This is a graph from the late 90s, you know. So long story short, house are being made airtighter. What about ACH today, and what does ACH mean? If you're looking at the bottom of the slide, you know, air change per hour at 50 pascals, this is with a pressurized blower door. In the real life, the real air exchange rate of a giving home is closer to 50, you need to divide that number by 15 or by 20. You know, it varies from one house to another one, and I would not be the best one to explain that. But so ACH 50 is not the real air change per hour. It is equal to a wind pressure of several 10 kilometers per hour. So it's not representative of the real air, but it's being used as an indicator for air change per hour. So in Novo Climat is an energy efficient program we have in Quebec. In the first version, they were targeting 2.5 air change per hour at 50 Pascal. The next version, they're closer to 1.5, and it would not be rare those days seeing zero point 0.8 to 1 air change per hour. In those range, mechanical ventilation becomes a necessity, and it is being made in new homes. What concerns me is has more to do with retrofits, especially retrofits where it's the homeowner who decide what he's going to do. You know, he's receiving advices from an energy advisor. Some retrofits are subsidized by the program, but at the end of the day, it's a decision of the homeowner. Interestingly, and the text is in French here because it's from Renault Climat, so the retrofits for the existing homes. If you're making your home tighter than the target value your energy advisor is giving you, they will give you more money. So if you're going above and beyond 20%, doing more ceiling, they will give you the subsidized increase. So let's jump this slide to be consciousness of the time. Uh, uh, it's important to understand that in the recent years, energy efficiency also hit the building codes. Interestingly, in Halifax, we had a project where we studied houses built before 2010 and houses built after. Why 2010? Because it was the time where the National Building Code was making mandatory the radon preventive measures. So we were interesting to see if radon preventive measure were efficient, and they were applied in Halifax from 2012. So unfortunately, we found more radon in a newer home. So a home built after 2000, but so after the application of the building code, it's the column in red. You can see we had stronger we have more occurrence, stronger radon concentration. So the energy efficiency could be involved. Um, it, Interestingly, there's a double dialogues. They are the energy conservation program or energy retrofit program. They are advocating that they will doing the retrofits will increase your indoor air quality. And as you saw, a good amount of international literature shown that some energy retrofit could lead to increase indoor radon. So that's a complex situation because we need to explain that to the public. You know, public they are doing those retrofit subsidized program. They believe they are in a security, and the program advocate that it will increase indoor air quality. So indoor air quality, it's a complex matter. Yes, it could increase some indoor air quality parameters, but certainly not radon. I don't like Chihuahua, by the way. So there some information are being provided in the inner guide report, but there's a clear statement that the energy advisor, the one who's doing the inspection on the home, he doesn't need to have the expertise on health and safety matters. So information is being provided as part of inner guide report on various concern, uh, uh, asbestos, radon, moisture, mold, but there's no clear link, you know, a causal link. So we would like to see this improving. We would like to see radon testing and mitigation being part of energy retrofits, especially when they increase. Now, another aspects of energy retrofit that could worst the risk of associated lung cancer has to do with equilibrium ratio that we were briefly presented in the previous concentration. So yes, radon itself is not the most dangerous stuff. It's really the two poloniums that are giving the radiation, the main radiation dose to the lung. So radon, to be dangerous, it need to age. So reducing the air exchange rate of a given building will give more time for radon to age. And that was documented in some research. And it's part also, Dr. Chen from the Radiation Protection Bureau of Health Canada studied equilibrium ratio across the country. And yes, ventilation rate is usually the most important modifying factor for the equilibrium ratio. So higher the equilibrium ratio, higher the decay products are, and higher the risk is. So some study shown that decreasing ventilation was linked to a higher equilibrium ratio. So all of a sudden, 200 becquerels per cubic meter, if you're increasing the equilibrium ratio, the risk is not the same. The risk is not the same at 0.4 equilibrium ratio or 0.7 or 0.8. The risk increase. So energy retrofits are likely to increase the indoor radon, and they are likely to increase the equilibrium ratio in certain conditions. That was such an interest that we were able to initiate a pilot project in partnership with the Quebec Lung Association in Quebec that gathers data from decades. So we contacted people who had already tested radon between 100 and 199 becquerels per cubic meter. We offered them, we asked them if they completed renovation, energy retrofit program. If they had, we asked them what have you carried, and we provided a free long-term alpha track detector to test afterwards. So we're looking to recruit 250 participants for this pilot. Right now, we only have 42 completed testing, so retesting after the renovation. So I'll be presenting those data. Interestingly, so interesting answer we receive from the participant. And I like here to make a distinction between the one who receive a subvention, who participate to a subsidized program, and the one who didn't. Interestingly, the one who, so 31 people who answered install or replace a ventilation system. So the one who had not received any subventions, they were more likely to install the ventilation system than the one who received a subvention. And ventilation is known and was documented if you bonify the ventilation to reduce radon. So it's something that could prevent the radon exposure. Interestingly, also, 28 people who answered had already tested radon after their energy retrofits. If we look at, again, the one who've received subvention, there were a minority. So only 2 of the people who answered retested radon after their energy retrofit. And the one who had not received any subvention, 19 out of 20 had already retested. Reported radon reduction. So some of who tested, they reported radon reduction, but again, it was rarely seen for those who had received a subvention. Now, so each bar here in the graph represent one home who completed one or several energy improvement to their home. On the y-axis, you have a percentage. This percentage, it represents the final long-term radon concentration over the initial, so the pre-retrofit, the pre-renovation radon levels. So when you have a bar above 100%, it means you have an increase in radon. Interestingly, we have not only seen cases of radon increasing, some cases shown decrease. The cube here you have represents what I like to call the level of uncertainty, plus or minus 30%. So now by types of renovations. So this first graph shows the most popular energy retrofit was changing the windows and the doors. So all those bars are people who had changed their windows and doors, and the other indication, like those, this first group here, also completing increasing air tightness, insulating the foundation, having heat pumps. So with only 42 data, it's hard to make statistic and regroup. So hopefully, if we get up to 250 data set, we'll be able to do grouping and see if we're seeing difference. But as per now, we're seeing cases where retrofits increase radon level, and we're seeing cases where energy retrofit decrease radon level, and we're trying to understand why. Interestingly, if you see on the graph, you have roof indicated. So people who had change their roof or increase insulation in their attic, uh, often their level was lower. So I regrouped all the cases on one graph, and interestingly, all the participants who made change. So again, those are only small data sets. We'll be it will be interesting to gather more data to see if this tendency keeps running. A possible hypothesis on why energy retrofit could reduce radon infiltration has to do with the stack effect. So in a given building, you have what we call the neutral pressure plane. So it means a place where the pressure is neutral. On the upper part of the building, the pressure is positive. On the lower part, the pressure is negative. And you have radon infiltration from the lower part because of the pressure differences from the soil and the inside of the building. So soil is relatively at a positive pressure. So by increasing insulation in the attic, it's possible that you reduce this neutral pressure plane, and therefore the pressure itself is reduced and the level of where it is applied on the building is lower. So that could be, this is just an hypothesis, but uh, interestingly, the forces that are making radon infiltration are the same force that are making radon exfiltration in a building. So it's an equilibrium, and energy retrofit could make both. So discussion conclusion already to be consciousness of the time. So among the parts, literatures reveal increase of indoor radon after energy retrofit. We observed that in close to 50 to half of the participant. Not only radon concentration can increase in a retrofit building, but if you're reducing the air renewal, you're likely to increase the equilibrium ratio, and that means something in terms of lung cancer risk. The literatures and the data reveal that increasing ventilation, adding a mechanical ventilation to an existing building could reduce the indoor radon, as well as sealing the entry routes from the footing. In the pilot project, we're seeing a tendency, but it's a small data set, but for improving the roof. So energy retrofit on the roof. Unfortunately, there are very few financial incentive in Canada that are including radon testing and mitigation as part of energy retrofit, and it's something we'd like to see becoming more popular. We have Manitoba Hydro, who is providing a loan for energy retrofit, including radon mitigation, but there are very few cases of those. So thank you for your attention.
Mathieu, we've had lots of questions. One from Dr. Shrestha. Has Health Canada had the opportunity to talk to energy efficiency programs regarding the issue of radon and retrofits?
Of course, we keep doing this. Yeah.
So you are advocating for, because now the energy grants have moved from the federal government to the provinces, correct?
There are still it becomes so diversified. We're seeing corporations, state corporation also giving subsidize. So it's but for sure it's becoming a reality, and we need to be we need to reduce our carbon. Carbon gas and energy consumption, but not doing it with increasing indoor radon.
And then one other question from Brian Rippey: does the Nova Climate program require mechanical ventilation like the BC Energy Step Code in new construction? Do you know?
In the building code, I believe that ventilation, mechanical ventilation with energy recovery or heat recovery is required. Yeah, it has been required since more than a decade. Yes.
Okay, so it might not be having an appreciable difference. And I think one thing I'd like to advocate here for is that people often talk about HRVs as a solution to the radon problem. Do you want to address that at all? Or would you like someone else to talk about that?
The newer homes are built airtight. They need an HRV to get a certain amount of air renewal without losing too much energy. Now, having an HRV does not prevent radon infiltration from the foundation and from the entry routes. So please test your radon even if you have an HRV.
Right. And I think this is an important part, even considering Colin's presentation earlier as well. Things that prevent radon from entering the home in the first place is the better solution than trying to dilute it once it's in your home or there's smoke in your home or your home is airtight.
Definitely. Correct the problem at the source.
Right. Well, thank you so much. Again, there's lots of questions. So if you wouldn't mind going through and just looking, or I know you may have to go, so you could leave your email if people could follow up, because there was lots.
I will put my email in the chat. So thank you again for having me.
Well, thank you so much for addressing this issue, and I appreciate that Health Canada is taking a role in trying to understand how energy efficiency can be impacting our radon levels across the country. This is only going to become a bigger issue over time. So thank you.
Thank you.
Okay. We're going to now take a bit of a step backwards, and we're going to hear from Dr. Liu, who's a radiation coordinator with the Radiation Protection Bureau of Health Canada. He's going to talk to us about radon in a changing climate vis-a-vis the Arctic. He works on environmental radiation monitoring and risk assessment. He earned his PhD in experimental physics from McGill, and he's previously worked at really fascinating places like CERN, and has done radiological analysis at Defense R&D Canada. So welcome, Dr. Liu. This is the first time you've come to speak to us at the BC Radon Workshop, so I really appreciate your taking the time today, and we're going to start your 20-minute clock now.
Yeah, sure. Yeah, thanks for the introduction, and also thanks for the BC Lung Association for giving me this opportunity to present this work. So the topic I'm going to talk about today is the outdoor radon dose rate in Canada's Arctic and the impacts from climate change. So how to move.
Are you able to advance your slides?
Oh, yes. Okay, yeah. So as we know, the radon is a big threat to the public health in Canada. in any given area, actually the actual exposure levels depends on a variety of factors, this including the environmental conditions. So due to the climate change, we know some of these environmental conditions have shown notable changes or trends over time, like this rising temperatures or the shifting precipitation patterns. So consequently, we suspect that the indoor or outdoor radon levels may have been impacted by those changes. So the study of the climate change impact on the radon exposures actually is limited so far and challenging because first, it typically requires long-term measurements on both radon exposures and also the relevant environmental conditions. Secondly, the climate change impact might be not observable or inappropriately interpreted because this really depends on how we manage all the other relevant factors and also how strong they are. So this work actually aims to study such kind of effect by using decades of the outdoor radon dose rate data we collected together with a couple of supporting data sets in the 2 Arctic regions. So our dose rate data were collected from the Health Canada's national dosimetry network, which is called the Fixed Point Surveillance Network. So the networks currently have more than 80 stations covering the main cities across Canada and ports, and also the areas close to the nuclear power plants and facilities. So the data from red blue stations and Yellowknife stations were selected in this study because the amplified climate change effects or the rising temperatures there is quite significant compared to the others. That's the reason. So those radon dose rate data were measured by detecting actually the gamma rays of the one of the radon property by using this sodium iodide scintillation detectors here. And then we did a spectral analysis and then convert the count rate into the radon dose rate. As we can see, our data actually is based on the gamma detections and measurements. It means those data represent actually the external exposures to radon. This is different from other, for example, inhalation or ingestion exposures. And it's in the outdoor environment here. This type of exposure actually typically low the risk. So in this work, we focus using this data to explore the climate change impacts rather than focus much more on the risk aspects. Again, because our data are based on these gamma detections, which means that the contributing sources to our signals can come from various surrounding medias. This including some the stationary source confined in the soil and the mobile sources like the soil radon gas and the radon gas in the atmospheres, and also some non-local source. Non-local sources is transferred from the other places, as well as there's a precipitation effect, which is caused by the radon progeny, which is carried down by the precipitation from the upper atmosphere down to the ground level and being detected. So the bright side of this data set is we have one single data set which contains all of these sources. However, the challenge part is that we need to separate each of these contributions in order to understand and interpret the data properly. So in reality, we often don't have all of the data needed. So in this work, we actually use the 3 supporting data sets to represent these contributing sources. This includes the potassium dose rate, which represents the stationary source contributions. The lead-212 air concentration data is represent the radon air concentrations from the local source, and the lead-210 air concentration data represent the non-local sources. Additionally, because the potassium dose rate, it varies mainly with the water contents along the path from the soil to the detectors. So this kind of data is also can be used to monitor the water content changes, which can be found either in the snow cover here or the surface ground levels, and also in the soil moisture, which can down to a maximum depth of 50 centimeters. So for the lead-212 data also can monitor such kind of variations, but it's only down to a very shallow depths of a few centimeters. This is because lead-212 is parent thoron and has a very short lifetime. It can only travel a very short distance inside soil. So regarding the precipitation effects, actually is quite it's kind of short-term effect in comparison to the seasonalities or the long-term traits which we are interested in this study. So what we did is actually just filter them out of the raw data. So in the end, what we have is one is the most radon dose rate data looks like this, and the 3 supporting data sets, as well as a couple of this meteorological data shown here. So let's move to the seasonality results first. So this slide shows how the radon dose rate depends on the temperatures, the left plot here, and the snow depth on the ground is the right plot here. So first point here is that the dependence is quite evident in both cases, and that the donut shape actually here just implies there is more than one variables or factors affecting our measurements. So secondly, the dose rate actually was found to reach the minimum as the snow depth. So here snow depth is maximized, which typically occurs in March in Yellowknife. And then it peaks in September before the temperatures drops below 0, and the snow can begin to accumulate. So this is typically occurs in the October, so we can see the drops here. So the snow influence actually can be understood by its shielding effect on the gamma rays. So snow here gamma rays, as well as its power to tracking the radon gas inside the soil. While for the temperature, actually its effect is indirectly, mainly through its impact on the water contents variations. For example, a rising temperature tends to reduce the water contents, either melt the snow or just drying the soil conditions. So as a result, this will reduce the shielding effect for the gamma rays from soil, and also can elevate soil gas emissions into the atmosphere. So here shows the seasonalities of each sources, individual sources. So the red trees represent the radon dose rate, while the blue represents the stationary portions of this dose rate, and this orange represents the radon air concentrations. So There is actually exists a few distinct stages or periods, while including the, for example, this rising, a quick rising stage in the spring months. This is due to the drying conditions overall, and also the suppression stage. This is for the stationary portion and also the radon gas concentrations. This is in the summer months. This is mainly due to the increased soil moisture due to the rain seasons. And then is the suppression stage in the winter months here. This is mainly due to the freezing soils as well as the snow cover. Actually, additionally, we found that in the spring months, in these months, the radon gas entering the atmosphere is highly diluted. This resulting actually a more gradual or slower for the molecular growth of the total radon dose rate compared to the stationary portions. And in the summer months, actually, we found the wet soil conditions is more effectively to trap the soil radon gas emissions than shielding the gamma rays. And lastly, actually in January and in February, we found that we suspect that the top 50 centimeters soil has been totally frozen. This result actually makes the radon gas dose rate behaves more likely to its stationary portion. So the ratios between these two is relatively constant. So the seasonalities in the red root actually is quite similar to those in the Yellowknife, except a few points. One is Yellowknife, red root has a very brief summer. So this makes this radon dose rate enhancement period actually very short. Secondly, in the early winters, because red root has this polar desert climate. So in the early winters, actually, we found that the soil freezing effect is more effective to tracking the radon gas inside the soil. Then I think that the water, for example, I think the water counting the changes, the freezing effect is more important because there's a little precipitations. And lastly, actually, in red root, actually the mean snow season is from September to November. So the large radon dose rate changes or drops happens mainly during this period of time. So here, almost it's the last part result is the long-term trends and also the climate change impacts. So here it shows the long-term trends, which is based on the annual means. So the Yellowknife radon dose rate actually has an upward trend over these years, despite its cooling temperatures actually we found over the last 2 decades. In red root, actually, there is no trend was found. However, its temperatures was found has been rising over the last 1 decade. So at this point, actually, it's hard to interpret all of those results or compare these two results here. So we did additional analysis to try to understand better. So first thing we did is split the data into 4 quarters. And then we did multi-variant regression analysis here. So basically this means we just feed all of the available factors into a model and then let it do two things. One is try to rank the importance of all of the factors. And the second thing is to derive the relationships between the radon dose rate and also the factors. So those are Yellowknife results based on the quarterly data. So the four plots on the top is the long trend results. The four plots at the bottom represent this factor ranking plots. So the main findings here is first, we found in the fourth quarters and the first quarters, the radon dose rate actually had the largest increase over the years. And we also found in the fourth quarters, actually the rainfalls in the pre-winters or summers actually is very relevant. So probably this can be understood by the rainfalls can cause for the overall soil moisture levels change, and these levels could sustain for a while to the winter or through all of the winter months. So in this way, this is the pre-winter rainfalls affect the radon dose rate. Well, in the first quarters, we found that the snow depths as well as the water contents in the very shallow soils is quite relevant. The second findings is actually is we found in some quarters, actually the temperature is the only factors which can explain the variations, but it's only about 10% overall variations, so it's not too much. And that they have positive relations between the temperature and the radon dose rate. So as it comes to red loot, actually found the radon dose rate remains in the winter quarters. Actually, there's fluctuate quite largely year by year. This is mainly because the snow changes in the fourth quarters. So at this point, we consider all of the trends is statistical insignificant, and then we need more data to really evaluate these trends. And in the summer quarters, actually found the increase on this radon dose rate, as well as the temperatures and pretty much all the other factors. And the relationship between radon dose rate and temperatures actually is quite moderate and with a positive relationship. So so how many minutes do I have? It's
just a few left, Dr. Liu. Sorry.
Oh, okay. So I just this last slides. So try to hurry up. So a little bit discussions actually in the cold months in Yellowknife, we found that both radon dose rate and potassium dose rate, there's an increased trend. And this actually indicated there's a reductions in the water contents somewhere. But this is not happening in snow depths because there's no trend here. So we suspect the water contents, the reductions actually happens in the soil. And if this is true, which means the soil pore space becomes more and connections is improved. So the consequence of this is actually indicated there's a higher chance of the radon gas to enter to some other environment like the atmosphere or the indoor environment. So in the warm months, actually in Yellowknife, we have only a weak relationship between temperatures and the radon dose rate. However, in Red Loop, we have a stronger one. Probably this is due to its unique geological or climate features in Red Loop because it has very shallow active layers. And also there's not much rain or the ground covers, which is interfering all of the response from air to the soil. And because there's an increase on the trend, pretty much for all of the variables in Resolute. So we guess what's actually happening is probably this is because there's a prolonged or longer warm days there. And also the permafrost, maybe thawing, just, makes these active layers becomes deeper. Well, so this is comes a kind of summary. Essentially, we think we found this long-term trends with likely to related to the climate change effect. However, as you can see, we use a lot of assumptions or the indirect measurements to derive our conclusions. So actually, we prefer there's maybe in the future, if possible, we use the direct measurements to improve the analysis. And also further details about this work can be found in the paper shown here. Oh, thanks. So that's all. Yeah.
Thank you, Dr. Liu. Perhaps you could put a link to that paper in the chat. So a few years ago, we also had somebody from Alaska who found similar results, that as the climate was changing, radon levels were increasing. They measured indoors, though, as well. Do you have any plans to look at the indoor levels in some of the homes in the regions where you're testing?
Actually, we so far don't have the indoor measurement plans, but we want to measure first the outdoor. It's not the dose rate, but the outdoor radon concentrations beside our stations there. So that's the first thing we think we want to do. But indoors, maybe in the future, if possible, why not just measure somewhere beside the stations to see if there is a correlation. So yeah.
Excellent. Well, thank you very much for a snapshot of this very interesting research that is going on here in Canada. I really appreciate that. And yes, if you wouldn't mind putting a link to your paper and your contact information in the chat, that would be really appreciated.
Sure. Yeah. Thanks.
Thank you. Please give our regards to Dr. Chen from BC. Okay. Next up. We're going to stretch again, everybody, and we're coming back. So that was the end of our international and our national guests that have come to talk about radon and the changing climate. I put some summary notes in here. I think that we've learned that things like wells can impact radon levels due to diffusion in more rural areas, that things like fire smoke and other issues that we're seeing in homes could contribute to increasing radiation doses for people if they're not dealt with. And that warmer, drier temperatures might increase radon levels over time. So now we're going to shift. And that energy efficiency retrofits the radon concentration issues seem to be getting worse. And we're also building homes where we might be trapping more radon inside unless we're dealing with subslab depressurization or mitigating it so it prevents it from getting indoors. Now we're going to turn to talking to some of the people who work in British Columbia about the work that they've been doing. So it's now my pleasure to introduce Stephanie Tuke, who is a member of the Wabaska community of the Big Stone Cree Nation within Treaty 8 in central Alberta. But she also lives here in interior BC. And I'll allow you to give your land acknowledgement because I'm just going to butcher the words because I'm not particularly savvy with a lot of those terms. Stephanie, I'll let you say that. But she works with the First Nations Health Authority, and she's part of their environmental public health service, where they deal with clean air, food, housing, and other vital programs. So Stephanie's going to give us a bit of an update on what's happening with Indigenous testing here in British Columbia. Go ahead, Steph. Oh, I think, Dr. Liu, I think you need to stop sharing your slides if you haven't. And then Matthew, can we spotlight Stephanie and her slides? Do you have slides to share, Stephanie?
I do, yes.
Okay, thanks. Okay, I think you have the floor now.
Wonderful. Okay. Well, thank you, Dr. Nicol, for introducing me, and I'm happy to be here. Thank you, Noah, for the invitation to speak today. Before I begin, I just want to say hello, Tanze. My name is Stephanie Tuke. I work for the First Nations Health Authority and am an Interior Regional Manager for the Environmental Public Health Services team, as Dr. Nichols had mentioned. I am Big Stone Cree First Nations and mixed European descent. However, before I begin, I do want to do a territory acknowledgement. I would like to begin by now acknowledging the lands on which we gather. I respectfully acknowledge that I have the honor and privilege to work, live, and play on the unceded traditional lands of the Silk people here in West Kelowna. And I would also like to acknowledge that the attendees of this workshop are joining us today from many places near and far, and acknowledge the traditional owners and caretakers of those lands. Just to head back to my presentation slide with continued momentum in the agenda, it says building momentum. I changed that because I feel that when Casey Neathwaite presented in 2018, he put building momentum as First Nations Health Authority was starting our journey with regards to radon monitoring within First Nations communities here in BC. And I feel that we're continuing with that momentum. So I have changed that title to continuing. Before I dive into the radon update within BC First Nations, I just want to give an overview about First Nations Health Authority, as I know that we have some attendees near and far and may not know about our unique health authority. So First Nations Health Authority is the first province-wide Indigenous-led health authority in Canada. Health and wellness, it's a health and wellness partner to over 200 diverse First Nations communities and citizens across BC. And it's a champion of culturally safe practices throughout the broader healthcare system. And part of the unique health governance structure that works in partnership with BC First Nations to achieve our shared vision, which is here before us, which is health, self-determining, and vibrant First Nations children, families, and communities. Again, I'll just share that our vision is above, but also that our mission is to achieve and enjoy the highest level of health and wellness by working with First Nations communities on their health and wellness journeys, honoring traditions and cultures, and championing First Nations health and wellness within the First Nations organization and with all of our partners. So to provide a regional landscape of First Nations Health Authority, we do have 5 regions as seen here. I am in the red section, and my update is going to be primarily focused on the interior region where I am and am the interior regional manager. But however, our radon monitoring is provincial wide. However, it is concentrated. I feel it's concentrated in the interior region, and that's as depicted here on the next map, which is I referenced from the BC radon map, where you can see that the highlighted red area there kind of mimics, and I'll head back to the regional landscape, our interior region. So we do have a very high indication of radon within our region. So therefore, we have enhanced monitoring within our First Nation communities. So just a little bit about the interior region in which we work. So we're the second largest region in British Columbia, with about 26% of the province's land base. We're home to 54 First Nations communities within 7 nations. So approximately about 22% of First Nations population in BC. And that's about 15,000 First Nations individuals who live within community. So just an update since we started our continued radon monitoring program in 2018, and the radon detectors in which we've deployed within community. So starting with the first 3 years from starting in 2018 to 2020, you can see a fluctuation in deployment. And there is one major highlight there, and that would be that's over the pandemic. So we limited our visits into First Nations communities at that time during COVID. So there wasn't a lot of deployment around that time. However, there was a high amount of deployment within 2019 as we started to build that momentum, but then the pandemic had hit. And then as we progressed throughout the years, 2021 again was in the height of the pandemic. And then we picked up momentum again in 2022. and 2023, we continue to rise within our deployment in the interior region. And then this brings us to this year, which is 2024, with 153 radon detectors that have been deployed. So that's a total of 574 radon detectors that have been deployed since 2018, which is significant and still ongoing. Quite happy that we are doing this monitoring. And I do want to say that we're the deployment of detectors within communities are within First Nations communities that are public facilities, community members' homes, and also within the schools and childcare facilities within community. So we have a basically, who wants a detector gets a detector, so I'm very happy and thrilled that we're able to do that for our First Nations communities. However, we've encountered some challenges. COVID was one of those challenges. Some of our detectors end up going missing here and there, or they do because of some of our rural and remote communities. It just unable to be retrieved because of accessibility and getting out there within timelines. Result error, so having to be redeployed because of not getting the result back. And then our biggest one is that we can monitor, however, it's the mitigation factor. To get into community, well, the availability of mitigators is one. Two, financial costs. And so there's one avenue in which we've tried to help overcome this challenge. And that is, we have, in partnership with Health Canada, I believe. However, we do have funding for to train community members in radon measuring and mitigation. So right now we're continually advocating and promoting this funding in order to get trained mitigators. So currently right now we have about 2 or 3 trained First Nations individuals that are trained for the measuring and the mitigation within British Columbia. However, we would like to get that number raised in order to help with the with getting individuals available to get into communities. Additionally, with the mitigation is that rural and remote aspects. So some of our mitigators or those individuals that could do the mitigation are centered in urban centers, and yet the challenge of getting into community to do that mitigation is sometimes a barrier. However, going forward with that continued momentum, Community Champions is one avenue in which we're hoping to get individuals within communities such as elders and youth to just spread the word of radon, what is radon, and do that health promotion and public health messaging within community with the support of the Environmental Public Health Services team and near and far within BC. Again, community mitigators. So we are hoping that we can get some trained individuals within community to not only service their community, but in and around to help alleviate that accessibility component to getting the mitigation and installation of and remediation. Partnerships and collaboration. So here in the interior region, we continue to work with and alongside Interior Health. We also collaborate with a number of BC organizations. I know that Dr. Nicol has come up time and time again within her work and alongside First Nations Health Authority. So we do honor and cherish those partnerships and collaborations because this work cannot be done siloed and alone. So, and additionally, we continue on radon monitoring. And you'll see my future aspirations is that to ensure that we have monitoring in every First Nations home in BC. I'm going to put it out there, and that's the goal. And then resource development. So just to quickly go through what and how we have started in this resource development. So we have created a couple of First Nations Health Authority resources in the way of one with the verbiage on the left-hand side of the screen, but also with the image on the right-hand side of the screen, just to showcase and provide to communities so that they can post on their community bulletin boards and their shared social media streams and however they communicate amongst each other, just to get that health promotion and information out. But not only have our resources been developed in English, we also recognize that there are language groups within different language groups within British Columbia. So here in the interior, we have started to translate some of these resources into the language groups in the interior. So we do have 7 recognized language groups in the interior region. These are 2 of them that have been translated. So this is Tanaha and Chilcotin. And so we've actually drawn and approached community to help develop these resources so that we can help getting the messaging to community members. And this is also available on our webpage. So I'm happy to provide that in the chat so that you can have access to these as well. So future aspirations, that all BC First Nations homes and public facilities are tested for radon. Mitigation funding, again, not only to get trained mitigators, but also to get to overcome the financial barriers of getting remediation in homes. That would be amazing if we can end up doing that, because that's one of the financial barriers. You know, the biggest question, okay, I have radon in my home, now what? And then, oh, I've already mentioned about the trained First Nations mitigators in all nations. So I will leave it there. That is the update that I have. And thank you, Kinetoskomatin, which is thank you in my Cree language. And I will pass it back.
Thank you very much, Stephanie. And those are some fantastic goals. So I really applaud you for taking on this initiative. I know that radon testing has been challenging, particularly during the pandemic, and it's so great to see resources available in different languages. So thank you so much. I know that the National Radon people will be very interested in what you're doing. So I really appreciate your sharing today. And I'm sure you'll have lots more. There'll be questions in the chat. I'm sorry we don't have time to ask you. We're running a bit late, but thanks so much for taking the time today.
Absolutely. And thank you for the invitation. I will provide my email address within the chat as well as that webpage link to those resources.
Yeah, fantastic.
Thank you.
Okay, and yeah, we really want you to use the BC Radon map. So it's never stealing. It is all, and in fact, that's who's up next is Jeff True. He's our environmental health scientist at the BC Centre for Disease Control. He is our man with the map. He provides the analytic and knowledge translation to support our environmental hazards, including radon. He does do other things as well, but we mostly hear from him around radon. So Jeff, with much no further ado, do you want to give us some updates to the BC Radon map, which is again for everybody's interest, publicly available, and I will be putting a link to the map in the chat. Go ahead, Jeff.
Yeah, thanks for the introduction, Anne-Marie. Can you see my full screen there? I was finagling a bit with my couple monitors here.
Yes, we can. The blue screen.
Blue screen, yeah, blue screen, big text. Okay, awesome.
Yeah.
So thanks again for the introduction, and hi everyone. It's really nice to see the number of attendees we have in the virtual room here today, and from all across the country too. That's fantastic. Yeah, so as Anne-Marie said, I work at our BC Centre for Disease Control, and I'm just going to give a quick 5-minute update on our radon data-related programs that we manage here. Before I jump into it, I'd just like to acknowledge that I live, work, and play on the traditional, ancestral, and unceded territory of the Coast Salish peoples, that being the Squamish, Tsleil-Waututh, and Musqueam nations. And the work that I'm going to be talking about today has been supported with funding from Health Canada and CareX Canada, just a couple public health agencies we have here in the country. So I'll start with a bit of background for those who haven't heard about these programs that I will be talking about. So for most folks, the purpose of measuring radon, of course, is to see if there's a need to mitigate a certain space or not. That's the primary use of radon measurement data. But there are secondary uses as well, especially if we can compile a whole lot of it. It can be used to help prioritize testing campaigns. It can be used in communication programs, or it can be used for research more broadly. The challenge is that radon measurement data has traditionally been held by different entities, different organizations. Now, this program, the BC Radon Data Repository, is an effort to bring this data together and remove that barrier, or at least mitigate it. So I won't go into too much detail, but some key program features. This is a voluntary data sharing program. We only use the compiled data for research and health protection work. We do not attempt to re-identify or contact individuals or re-identify buildings. We also make this data available for external parties to request access to, but again, only for research and health protection work, with no ability to re-identify individuals or buildings with reasonable accuracy. So 2021 is when we had an initial set of data to work with. We launched this in 2019, 2020. There's certainly some pandemic-related delays there, I do recall. So 2021 is really how we had something to work with, and then 2024 now. So in the past 3 years, we have approved 6 external requests for data, and I'll summarize them really quickly. One is the recently published report of radon summary statistics across the country. This was led by the Evict Radon research team, with collaborations with staff from Health Canada, Carix Canada, ourselves at BC CDC as well. The compiled repository data has also supported 2 reports published by BC Lung. One is to advocate for radon regulations in workplaces. The other is to recommend radon testing in higher risk communities with less known testing to date. Another external project was the master's thesis, which examined the association between residential radon and hydraulic fracturing. And there are 2 ongoing studies at the moment, so keen to see those results when available. Another way people access information from the repository data is through our online public-facing map. Stephanie showed a screenshot earlier, and yeah, like again, it's a public resource, so we're really excited when folks in the general public, other stakeholders do use it. So with our compiled data, we have found many more communities throughout the province with extremely high radon exposure risk. These are communities where there's 1 in 3, 1 in 2 chances of finding a home with problematic radon exposure. And this is some of the highest exposure risk globally when you compare to studies that do compile the international data. Another thing is that historically, Vancouver Island, the Lower Mainland, and the coast were considered these areas where there's very low probability of finding a home with problematic radon exposure. We see a more nuanced picture now with areas such as Cowichan Valley and Fraser Valley being hotspots, and there's otherwise cooler surrounding areas. And to illustrate this comparison of what we knew in the past to what we can show now, what we do know now is the map on the left is from residential testing that BC CDC did back in the 90s, what you consider the really early days of radon exposure surveillance in this province. On the right is a screenshot of our map today. So yeah, there's a link there. I think Anne-Marie mentioned she's going to throw some links in the chat. There's a QR code there to point your phone camera to as well. So we launched the map in 2021 as well. And since then, we've received feedback sort of on an ad hoc basis, having conversations with folks, stakeholders, all that sort of thing. And we made some minor improvements here or there. One issue is that the map was never mobile friendly. We designed it for a desktop. It always worked on phones, but features overlapped. It was clunky. It didn't really work. It didn't really look that great. So we made some revisions to fix that. And then also we're currently soliciting feedback through a survey. We're looking to get opinions on how the product is designed, what people think, where we can make improvements. We're looking to see what sorts of people use this map. And if they've used this to inform their work in any way, that's really helpful for us to know. So please do take a few minutes to fill out this survey, whether you've used the map in the past, you're kind of coming back to it now because this prompt, or you're just accessing this for the first time. One lucky respondent will win a $100 Canadian Tire gift card. So there's a little bit of an incentive there. So all of this work that I talked about is made possible by our data providers. We currently have 19 of them. In total, their contributions make up about 44,000 unique measurements. So I'll end with this. If you hold radon measurement data, regardless if it's from residential settings or not, and you're interested in contributing to the type of work that I've described today, please get in contact. I can throw my contact info in the chat as well, but I have this last slide with it here and long list of acknowledgements of both internal and external contributors to this project. I'll stop sharing my screen there.
Thank you very much, Jeff, for that short and sweet update about the map. It is amazing what we've been able to do in BC, and we continue to be the only province that has this publicly accessible resource. So thanks to you and all the effort that you've done in bringing this together. It is incredible. And there's a new publication out about the work that Jeff has done. So we can put a link to that in the chat as well. Thank you. I'm sorry we don't have time for questions to ask out loud, but likely there will be people in the chat. So please go ahead, Jeff, if you don't mind. And if you could put your email in the chat, people would appreciate that too. And last before least, before you have to listen to me give a slightly more regional update, and I am sorry we've run over time, but it's been such an interesting session today. Next up is Trevor Coote, who's a former managing broker and realtor. He is now the CEO of the BC Real Estate Association, but he's also served as the CEO of the Kamloops and District Real Estate Association and the Kootenay Association of Realtors. He has a degree from the University of Saskatchewan and from Royal Roads and is Master of Law from York University. So Trevor, if you're there online, I know you have a bit of time constraint. So Jeff, I think you need to stop sharing your slides. So Trevor, do you have slides or were you just going to talk?
Yep, I do. Yeah, just waiting for that.
Okay.
Now I'll do the obligatory fumbling to see if I can make this all work.
That's okay. And thanks to all the realtors who have joined us today. I know there's been a lot of science this morning, but the question is climate change impacting radon levels? I think the answer is yes. Do we know how much? Not yet. And is it scientifically plausible? Yes. So how you doing with the?
I'm so close.
Share screen. Okay.
I promise. How's that?
All right. I can see that you've started screen sharing. There we go. Yes. Thank you very much.
Excellent. Well, thank you so much, Anne-Marie, for the invitation to join everyone today. As Anne-Marie mentioned, I'm the CEO of the BC Real Estate Association, and we were really happy to put some effort, some initiative, create some partnerships to do our own campaign around the awareness related to radon. It's sitting through some of these sessions today in the background. I mean, there's a lot of information out there, and the question is, how do we get that information out to the folks where it matters most and create that awareness? And so we saw a role for BCREA to help bridge that gap. I often joke about when I'm in crowds of people, I always think to myself, I wonder how many of these people are realtors. And Anne-Marie pointed out that there might be some of you folks on the line today. So it's our privilege to represent 26,000 realtors in the province of British Columbia, 26,000 individuals who are related to real estate transactions and housing. And what better way to get across the message of the importance of awareness around radon than through those individuals and the tens of thousands, if not sometimes, some years, hundreds of thousands of real estate transactions that happen in the province. So I'm just going to very quickly walk you through what that campaign looked like for us and how we were able to bring that awareness. So the objectives of the campaign, very straightforward. We wanted to make sure that realtors were aware of the issues, the challenges with radon, but also kind of differentiate between our realtor population and our realtor advertising and marketing versus what we could do for a public awareness campaign. And what we really wanted to make sure of was that when the public approached a realtor, the realtor wasn't caught off guard, that the realtor had the resources available. Maybe they hadn't seen all of our materials, maybe they hadn't opened the emails, but at least the materials were available for them when they needed them during a transaction or during the conversation. We also wanted to obviously encourage the use of radon testing, test kits, and so that became a big part of our campaign. we did this through partnerships. A lot of what the BC Real Estate Association is trying to do going forward with the myriad of issues around housing. And what was interesting was to see we do a lot of advocating beyond things like radon and certain practice issues related to realtors. And we do have a lot of conversations around housing. And so it was fascinating for me to see that there's such a connection between some of the energy efficiency protocols that we see coming into place. We're doing a lot of advocacy around offsite construction, which automatically or typically has a direct connection to energy efficiency. And so what are the radon implications around all of that advocacy work? I hadn't made that connection before, so it was interesting to see that as well. But we're doing this, did this campaign in partnership as well. Partnership with BC Lung, of course. The Real Estate Foundation of British Columbia is a common partner of ours to help finance and amplify some of the things that we do. Spring Advertising, the company that was used and previously used, familiar with this type of work. And a shout out as well to Saskatchewan Lung, who I'll mention later on in the presentation. So the key project deliverables was a landing page, an actual landing page, a resource that all of our advertising pointed to. Again, going back to that realtor awareness component so that they knew that there were resources available when they were entering into the conversations. And then more of the public focused campaign, around online digital advertising and that kind of thing. So the digital advertising, exactly as you'd suspect, a lot of ads on Google, YouTube, targeted advertising, ended up with 1.5 million impressions to date. We had other traditional advertising through radio, maybe less traditional through podcasting, and then on global television. And then 2 billboards in kind of high areas of radon outside of Chilliwack and Kelowna. And I will say, just on a personal note, that these were some initiatives. We have a handful of realtors who are real champions in this area. And I have to give shout outs to those people. Out of 26,000 realtors, we can do our best to make sure that we're getting the message to 26,000 people. But when you have a few folks who are real champions on a particular issue, as we've seen from all of the presenters here today, take it really passionately, it's easy to amplify some of those voices. And so we put billboards in those areas to recognize some of that effort as well. And then coming back to kind of the key area that we were able to drive all of those advertising initiatives toward is the landing page, and making sure, again, working with Lung Saskatchewan, building out the landing page, putting the resources there, and the availability of the testing kits, people able to order them right on the landing page. A couple of screenshots from the landing page, again, ordering the testing kit, making that super easy for folks. And then a little bit of education around radon as well. And then we did other initiatives, some video content and other things that were shared on our social channels in order to amplify all of that initiative. And a lot of it was, so now moving into kind of the realtor focused area, we focused our attention on the realtors and have been for quite a while. As you can see, it started in 2020, our work with BC Lung. So really trying to coordinate some of that resource, some of that information towards realtors. And then the public campaign was really driven around Radon Awareness Month, which of course is November. So really using those two, differentiating between those two audiences, and then encouraging realtors to participate in some of our initiatives through, as you see, a frequently asked question quiz and contest. And I have no idea what we would have given away, but typically it's a tablet of some sort. So I'm sure that's what somebody is enjoying today. I know that we are running behind. I wanted to keep it very short and sweet. I can put my email in the chat if folks are interested in reaching out to me or one of our team to get more information. I will say, and I'm going to say this unfairly because I have nothing to back this up. I haven't talked to anybody internally or externally, but any of the resources that we've developed, I always tell our team, just make them available to others. Anything that we do is non-proprietary. And we just want to make it easy for others to be able to do similar things if your organizations want to mimic what we've done. So.
It's been so fantastic, your involvement. I can't say enough good things about the leadership that your organization has taken in promoting radon awareness amongst your members. It really is. And I put in the chat, like, we are scientists, but you guys are the interface with the public, and you reach far more people than we are ever going to be able to get to come to the BC Radon workshop. So your contribution to this field and actually helping to prevent people from getting lung cancer, like, I really want realtors to know that they are helping to address this still outstanding and leading cause of cancer death. So I can't, thank you so much.
Really appreciate those words, Anne-Marie. And I mean, obviously, it's a team effort. Our team has taken this extremely seriously. Like I said, we've got some champions on the ground that really spearheaded this conversation internally. And I appreciate all the work everybody else is doing to be able to support and create the messages that we're sharing out to our folks. So appreciate that.
Yeah, and realtors, we're here. So the BC Centre for Disease Control, there's expertise. Have you seen a myriad of people who are doing radon research? Health Canada, your regional radon rep. So if you have questions or you'd like to learn a bit more about radon, we are always here and always available to help answer those questions for you or your clients. So please reach out.
Absolutely. Thanks again for the invitation.
Okay, thanks for coming. I'm going to do a very quick and dirty summary of what I was supposed to talk about. I know we're almost at the end. I'd like to say thank you to Riley Condon for her assistance with this project. I wanted to give people an update on the fact that we do have digital detectors in libraries across BC. We've been trying to figure out where they are and where they went, and are people using them? The first phase of the research, which was funded by Health Canada, we found that about 36% of libraries in BC now have digital detectors. I know some of you have personally helped contribute to making sure these are there, so thank you so much. They are not equitably distributed. Interior Health has more than other regions, but they also have other issues with them. So we have none on Vancouver Island. I'm sorry for the folks in Cowichan and Victoria that have come on board, but we are trying to fix this problem. Now we know you don't have any. We will be targeting libraries in your area. We know that libraries are also lending the devices with other kinds of air quality monitors, which is really interesting, and that not all libraries provide the same information. We also asked about wait lists. And I think that people in the interior, you won't be surprised to know that you have over 400 people waiting to take digital monitors out of the library. Health Canada has developed a new program where you can get a promo code to buy an AlphaTrack detector at a reduced cost. This is rolling out now. And so people in those regions, I know in Oliver, we had someone say that they could already get the promo code. If you're waiting for a digital detector, it is worth your time to use that code to get a subsidized test kit and start testing your house for radon. We did an analysis of regions where the radon levels are high and where we think more library detectors need to be placed. These include Prince George and Fort St. John, more in Oliver, and we're trying to fix that actually in the next few weeks. Oliver, we're trying to get detectors to you. Fraser Health, we could use a few more out in the eastern part because those are also many of those on hold, and in the Sea to Sky corridor. And again, Vancouver Island, we see you and we're working on it. We're going to talk to librarians. So I just wanted to give a quick update to Oops from BC Cancer, who also has been working with us. In Kelowna, Dr. Siavash Attrition continues to do radon research with patients. They have been promoting their research in different cancer conferences. The BC Cancer Library now lends devices to patients, family members of cancer patients, and to researchers. If you are within the BC Cancer or PHSA system, you can access a digital device from the BC Cancer Library. If you just would like to look at it and see what it can do, these are Carentium Air home devices with a digital display. And then just hats off to Dr. Gurpreet Sandhu in Surrey. She's been doing so much to promote radon awareness within her workplace. And she's now also providing free test kits to people who work at the BC Cancer Surrey site. So we'll learn a little bit more about what's going on in that region, because Fraser West continues to be an underexplored area for radon. And I think I'm going to stop. Oh, no. And then just a quick update on the 100 test kit challenge. So up until this year, 34 communities have participated. And the data from those initiatives go and feed into the BC CDC map. So thank you to everyone who's taken the time to test. And then just to say that this year, we have some new people all the way up in the northwest part of the province in Atlin, BC, all the way down to the southeast. And then, yay, Vancouver Island, we're starting to get some data for the northern part of the island. So these are the 9 communities that are testing. We also have renewed testing in the Okanagan, where we know, again, those levels are some of the highest in the country. So thank you to Nancy Mora for all your ongoing work promoting radon testing in the Okanagan, and to Dr. Sandhu for helping to get people in Surrey galvanized for free for their workplace. Okay, and that's me, my very quick and dirty roundup. It's noon, so it is time for people to go, but if you'd like to stay, I think we have a bit longer here on the line. If you have questions or questions for the speaker, we're going to stick around. So I know that was a really scientific program for many people. We did want to talk about radon and a change in climate. I think I put some summary points, but I can take questions now. Noah, I don't know if you have any outstanding questions on the line that you would like to read out, because I've been talking.
I can look. I didn't see.
Okay.
Yeah, no, I mean, we've been.
Oh, I had a radon in drinking water, uranium in drinking water question I can answer. So there's an issue of radon in drinking water, but uranium in drinking water is a different issue, and it leads to kidney disease. So if you have elevated levels of uranium in your drinking water, there are ways of filtering it out. You can do that at the point of tap, or you can do it in the broader system. But exposure to uranium in your drinking water is not great. It's part of the metals profile. So if you do have your water tested, it will automatically tell you what the uranium is if you tick the metal box. If you want to test for radon in water, that's a more involved process. You have to be able to capture it without any air getting in it, because it will off gas into the air. So it is possible to test for radon in water, but it's not part of a standard water profile that you would get if you just took a sample and submitted it to the lab. Okay. That was a lot. Lots of people saying thanks.
I think people are starting to trail off, but there's still some people there. I mean, should it be, Dennis Fudge asks, should it be mandatory testing for all residents that rent their basement as an apartment? They're collecting money from others' health.
Mm-hmm.
I mean, I don't mind answering that.
Do you want to turn your camera on?
Sure.
Okay.
We actually have quite a lot of materials at BC Lung on the rights and responsibilities of renters and landlords. We came out with a guide for landlords and a guide for renters. Yeah, absolutely. Under Section 32 of the Residential Tenancy Act, there's a provision that rental accommodation be safe, and we think that means that landlords have an obligation to test. And we actually created a checklist to help landlords or tenants test their spaces. We created a process for renters to ask their landlords, but renters can test themselves, and they should use a checklist to make sure that they do it right and then present it to their landlords. And it would be possible to go to the residential tenancy branch if need be.
Is the recording of this going to be made available, Noah?
I think so, yes. But I'd like Men and Matthew to chime in on how they're doing it.
They have
Yes,
said
it will be available very soon, and we'll send out an email to all those who participated and make it available on the website, the BC Lung website.
Great. Thank you,
Some
man.
realtors want to get credits. I think Men, do you have a way for that to happen?
Okay, I have not talked to Pam, but I don't see Pam's name in here. But I have several people asking for certification, and we'll work that out with Pam.
Okay.
All right. Yeah, I just had some comments about energy retrofits. So it's important. I hope people heard this conversation about how energy retrofits can seal up homes, and that please spread the word. if you have a home that has been retrofitted, even if you tested for radon before, it behooves you to test again. And if you could help us raise awareness with energy advisors and other people that this important process that's going to save you money may also be inadvertently impacting your health. So it's really a good idea to make sure that your radon levels are still low after a retrofit's happened. Oh, CNRPP people would like professional development points too. Okay, I hear you. I hear you, Jackie. Are there guides for doing your own radon mitigation? Actually, yes, there are. So Mathieu, I don't know if he's still on the line here, but Mathieu helped author some of those guides. They are available from the federal government, so I can put those in the chat.
Are you gonna do it, Emery? Shall I find it?
Okay. Okay, why don't you go ahead? Oh, BOABC. So building officials would like to have certification as well. Okay. Yay, 2 for BO. I'm great to see people here from the Building Officials Association. That's fantastic. Great. I'm glad you guys could all come today. Really appreciate it. There's lots going on in this world. The relationship between wells and proximity to wells to homes, I think really, the more we do radon testing in rural regions, the more we are seeing these elevated levels. And it's the well part for me is such a curious piece of, why that might be. There's no particular reason why homes in rural areas should theoretically have higher levels otherwise, like single bungalows. So this has been a really interesting sort of shining a light on what for me has remained a bit of a mystery. How can policymakers integrate radon concerns into broader Arctic climate adaptation strategies? Franklin, that's a very interesting question. Wow. Franklin, one of the places you might want to look is to Alaska. I think I'd mentioned earlier that in Alaska, they have, because the climate change there is so significant, permafrost melting is really destabilizing many communities, and they are seeing not just radon, but other compounds be liberated like arsenic and methane, that they are starting to have some policies that really do address warming and the buildings in general. So that might be one place to look. Dr. Art Nash is part of their extension, like here.
I could say something else.
Yeah, go ahead.
Yeah, is that what we're seeing is that radon's largely unaddressed at the provincial and territorial level. Health Canada does a great job, but the sort of on-the-ground laws and policies generally come from the provinces and territories. And so we're seeing that climate change is making radon worse. And I think as a response, there should just be radon protection policies. It can be part of climate adaptation or part of general public health. And so I think Health Canada has actually put out guides for provinces and territories and for municipalities. And I think it's just time to start moving on them. And climate adaptation is a good reason to do it.
Oh, we have a shout out for architects as well to also have a professional development. Man, you're going to have your hands full, right? In professional.
I know. Okay, I have emailed Pam regarding the CNRPP professional development hours. So I'm pretty sure she will grant us some.
Okay. Oh, there's lots more questions. Nova Scotia Working Group is concerned that the library lending program won't complete long-term tests if the results are below 200. So in BC, we do have this program now where we provide coupon codes to people who get the detectors. And we really emphasize that this is a screening program and that in order for people to complete testing that they need to purchase a long-term kit. And then we have a code that gives them a discounted rate. So that is one of the ways, Peter, that we are addressing the issue of short versus long-term. We are also trying to get libraries to lend those Carentium homes for longer. So analyses that have been done by CNRPP have found that the Carentium home devices or the AirThings devices are quite accurate if they're measured for longer. The problem and the tension right now, especially in Nova Scotia and in the Okanagan, is that those test kits are in hot demand and people don't want to give them back. So the library lending period is usually only 2 weeks. So can we get libraries enough devices so that they can extend that lending period for longer? And then if people are testing in the winter, it might relieve that sort of long-term, short-term issue. And there's a bunch of technical questions. I see Greg is trying to help people answer some of those. So thank you, Greg. Okay, well, I think
Todd Griffiths asks about depressurization installation details. And I can't find the question, so he should maybe just ask it again.
In the meanwhile, there's a question about geothermal heating in larger buildings, or more concerning schools with geothermal heat and a sports field above. Geothermal heating can increase radon levels in homes. That is one of the things that I think that Kathy Ryan's presentation did point to is when we are digging down into the ground, we may also be opening up these conduits for increasing radon in the home. So geothermal systems, the concerns around making sure that they are sealed and that there is no communication from the slab into the home, and then having a radon mitigation system would help draw whatever gases are pulled up safely up and out of the house. So that is, I know, an area of increasing concern, and I don't know how many specific resources are provided on geothermal, but the Canadian Radon Association is looking at that as an issue. Thank you, Gurpreet. I'm sorry I had to go so fast over your slide, and thank you so much for being such a champion in the Fraser Health region. Is radon half-life impacted by the temperature at all? By an anonymous attendee. I'm not a physicist, so I'm sorry I am not qualified to answer that question. I think Dr. Liu is already gone. He might have been a better person to answer that question than me. I'm sorry. We can add that to a list of things that we send around. Any other questions, Noah?
Well, I'm responding to Todd Griffiths, who asked a very technical question about infill material. So I guess I could try and do it orally. If there's subslab grade built on the foundation and it's 2 to 4 inches below grade, does the polyethylene membrane have reduction in efficacy if it is installed below the infill material as opposed to immediately below the slab? Well, the infill material I think he's talking about in the BC building code, I think the national building code as well, is generally a porous layer of gravel, which is designed to have communication of air. And so the purpose of, sorry, Todd wants to speak. I don't know if we can give him speaking power. I don't know how to do that.
I don't know that we can.
Yeah.
Okay.
You
well,
can.
Go on.
Can you guys hear me now?
Yeah.
Oh, okay. Yeah.
Oh, that's great. Thanks so much. I'm sorry I'm not trying to hijack this from everybody. I just have had this question and I've spoken to a few people since radon depressurization rough-ins have become required in the BC Building Code since March of this year, with the new code being implemented. Some of us building officials are scrambling a little bit to find some good systems and work with our local building community to find good rough-in designs. And I've posed this question with a few people with some limited success and figured I would try here. So to clarify a bit, we do a lot of what we would call slab on grade style construction. So level building lot, pour a footing and a foundation for a single family home. That footing and foundation would dig down below the frost line, which is not that deep here in Pell River on the coast. So say we go down 2 feet, 4 feet, whatnot, to find good bearing capacity on the ground, pour a foundation, and then we would usually infill that with some sort of occasionally native material, but at sometimes and most often some sort of sand from a local pit. And then as per the building code details, we would have a polyethylene layer, a layer of gravel that would be on top of the infill material, with some sort of depressurization pipe, 4-inch pipe that would run up through, either in this case roughed into the building and capped off for future provision, or right up through the roof. And herein lies my question. I've had a number of people ask if they cast the foundation, the footing 2 feet, 4 feet down below the grade level. Could they install said polyethylene layer, so the barrier per se, on a layer of gravel down at the footing height, which would be in some cases, again, 2 feet, 4 feet down from the actual slab, and then rough in a pipe that would go up all the way to above the slab height, and then infill with material on top of the polyethylene. This, for a lot of my building community, which is small here, they feel that this would be a lot simpler for them and more cost effective for a variety of reasons. I was just curious if you guys, maybe not, could weigh in on whether there's increased risk by having some sort of infill material, whether it's pit sand or whether it's native soil that was excavated when they put in the foundation, whether we're increasing the radon risk in the building by having that polyethylene layer lower than immediately below the finished slab. A lot of talking there. Sorry, guys.
Yeah, my view is that you would be not following the code properly.
Okay.
And the reason is that the purpose of the polyethylene is to create a impermeable membrane between the porous layer and the inside of the building.
Mm-hmm.
And the reason for the porous layer is to create communication so that you can collect radon gas and other soil gas through the pipe and out. And the purpose of that membrane is to basically seal it in so it doesn't get into the living space. If you didn't have the membrane, there'd be a greater chance of escape of gases through small fissures in the slab, which would actually create all sorts of problems for creating subslab depressurization.
Right. So keep in mind, just to make sure we're on the same page here, keep in mind, we're not talking about removing the membrane, but rather just moving it lower. So instead of sealing it to the edges of the foundation below the slab immediately, and usually insulation, there's usually rigid foam in there as well. I'm talking about moving it lower down on the foundation line, so closer to the footing. So still having a continuous polyethylene layer just below the infill and sealed below the infill, as opposed to above the infill. And was just, and again, you may be right. No, I'm not by any means here arguing against you, but just trying to really understand the best installation detail. And as a quick side note, part of the challenges that I'm facing is that by having that polyethylene layer installed below the slab, a lot of the installers are moving to thicker polyethylene, using trying river rock as opposed to any sort of sharper rocks, because they're seeing some failures in the polyethylene layer from just general use and installation. So people are walking all over this poly, which is on a bed of gravel, which can sometimes be sharper, more risk of tearing, which is to some extent counterintuitive to what we're doing previously, which was installing it over a layer of sand, which would not be acceptable for radon depressurization. Anyhow, yeah, I really appreciate your time. I feel bad that I've hijacked this for the past 5 minutes here, but yeah, it's great.
I have something to add to that. So Greg Batalon has actually put his offer too. So Greg's been doing this for a long time in the interior health region. He'd be a good person to reach out to. And if you don't, Greg, can you put your email in the chat, please? So you've also hit on a pet topic of mine, which is radon in aggregate. And, because aggregate has a lot of surface area, there have been studies that have shown that gravel itself can be a contributor of radon. So it really depends on what what are you putting on top of that sand? And even if it is a local, sort of material, or if it comes from a bit farther south, like, we don't have policies that compel people to test infill for radioactive materials. So you might end up just putting, radon-rich rock up above the plastic, which would be sort of defeating the purpose. So yeah, that's also a risk. In the Okanagan, this has been talked about more fulsomely because there are quarries with levels that are likely very high. And I admit to having a pet project where I have baggies full of rocks that I've collected, and I put the radon detectors in them to see just what is gravel got in it. And some of the levels are kind of high. So this is a concern with that strategy, would be not protecting people from the surface areas of the gravel that would be emitting radon.
I'm going to suggest that we take this to some email conversations, and maybe we can get a separate webinar and get some experts too, because we went through and did this with the building code a couple of years ago. And we've been thinking it might need to happen again with the new changes across the province.
Peter Fleming has also chimed in here too. If the membrane was installed at the footing, there could be a risk of radon entering through between the footing and the slab and collecting in the gravel. Anyway, yeah, I think this is a good idea, Noah. If folks are, I'm assuming these are mostly building official folks or building trades people that are asking these questions, because we could have another webinar just on the implementation of the new code and some of the challenges, especially because we've got people who've had expertise with this already in different parts of the province. So maybe they could come and talk a bit about some of the things that they've found, and the issue of people stepping on the membrane and it breaking in the gravel. Like, that's a really good point, Todd. And I think we'd all benefit from learning more about the actual like code in practice would be really useful. Oh yeah, Jen is chiming in, currently 6 mil, but now the building standards recommend 10 mil. So yeah, I think it's a good idea, Noah. Let's schedule a webinar on this specific topic for this area. Okay, well, unless anyone else has other questions, or if you'd like to share your email with other people on the line, that had kind of been what I thought we might do for the last half an hour if we had the opportunity to chat. But it's nice to make connections with people who are interested in working on radon from all sorts of different sectors. You can see where there's scientists and atmospheric scientists and home builders and researchers and realtors. So it's building officials. It's great to see everybody come out. Oh, and Noah's answering a question. Okay, thanks, Peter.
Someone asked about protecting from radon when they're upgrading existing homes, making them more energy efficient. The very simple answer is you test after the upgrade. The other thing you could do is talk to the renovator to see if it's cheaper or easier to put an event pipe during the efficiency process. We actually created a guide for renovation that I'm happy to show people. It's on our website. I'm going to look for the URL for it.
Yeah, you should put that in the chat. Oh, that's a good point. So if you are continuing to be interested in radon, there is the National Radon Conference, and it is coming up this year in the beautiful province of Quebec, in Quebec City at the end of April. So watch out for announcements for that. Will be an in-person conference, but there'll be lots of new research. We'll get the big Cross Canada update where they've shown that radon levels are actually, there's more people living above the 200 Becquerel guideline than we had thought before, a more than doubling of the previous estimate. So there'll be lots of discussion about that and many of these other issues.
An anonymous attendee is thinking about becoming a radon mitigation tester and wonders if this conflicts with free kits available from libraries. And the answer is the free kits are to help people understand radon and to take short-term measurements. And that's just a very different thing than the context where someone would hire a professional tester. Professional testers have all sorts of uses for when people really want an outside expert to have done the testing right. So we'd encourage you to become a certified radon tester and not worry about the monitors, because those are just a way of informing people. And we always tell people who get the digital monitors out from the libraries, follow up with a long-term test as well.
They're really an educational aid to get people thinking and talking about radon and realizing how much levels can change over time. So Gurpreet, it's true, some people are concerned about property disclosure and radon, but I can tell you in the Okanagan, where people know radon is a problem, it actually becomes a bit of a selling feature. So as awareness comes along, people are realizing that they may have to fix a home for radon. And if it's already been done and people can show people the system, or they can provide them with the results from a longer term test, I think that this actually will add to people feeling confident that they're buying a healthy home. So, yes, that people do voice those concerns, but I would point to the Okanagan as a place where the cat is out of the bag in many ways. Everybody knows that radon is an issue in that region. And so people will be asking during a property transfer. And if people haven't tested, that could be a sticking point too.
Another way of putting that is because so many homes in the Okanagan have radon, it will likely become almost standard that there's a holdback clause negotiated, in which case it should be economically about the same as to whether or not you simply make a deal as part of the transaction that radon will get fixed, or you fix it before and then say it's already fixed.
Yeah, 1 in 3 homes in the Okanagan are above 200.
Yeah, Dennis Fudge writes, I've used the radon mitigation as a selling feature for his home in Prince George. And I assume it worked out pretty well.
Great to have people from the north attending, Dennis. Thank you so much for coming. Okay, I don't see too many. Oh, Dr. Liu, are you still there?
Oh, yes, yeah.
Okay.
Oh,
I'm sorry, did you see the question about the whether or not temperature influences the half-life of radon gas?
actually, I replied, I don't think so, actually. And I don't know any variables that can influence the half-life. Yeah. So I actually replied, yeah.
Oh, you did. Thank you very
Yeah.
much. Yes.
No worries, yeah.
That was my sense, but that was just a guess and not as much of an educated guess as your response. So thank you for answering that question.
You're welcome.
Is there any other Health Canada research that you quickly wanted to share, like that projects that are ongoing in the north?
From me?
Yeah, is your group doing other work in the north around radon, or is this the main initiative?
Actually, we plan to install some outdoor radon measurements in Yellowknife, and probably indoors as what you suggested and asked. Yeah, so I think there's 2 main things we are working on. And also, we are actually being invited by the Nordic countries like Finland and Sweden to work on some radon measurement and also the climate change projects. So that's what we are working on. Yeah.
Interesting. Well, I hope to see you and meet you in person in the Karst conference, which is coming up in Quebec City. Hopefully people will be able to travel from Ottawa to Quebec City and give us some updates on what the National Radiation Program has been doing.
Sure, it would be lovely. Yeah, thanks.
Well, thank you so much for coming today. It is 12:30, so we should probably shut the door on the workshop, but I appreciate everyone who spoke today. It was a varied and interesting discussion on lots of different topics. And yeah, hopefully people have shared their email so they can ask questions to some of the experts that have come online. And yeah, I hope we'll see you around this time next year, or maybe we will see you at Karst before then. And if you have any questions, BC Lung Foundation, just send us an email and we'll get back to you. Yeah, thank you, Stephanie. I had lots of requests for your email, but so thank you for putting it in the chat.
Absolutely no problem. I actually got some emails already, so.
Good. That's great. Yeah, great work. And I'm sorry you don't have enough mitigators, and whatever we can do to help improve that. I know it's something on Pam's agenda for Karst as well. So that's definitely a work in progress.
Yeah, I think we'd be really happy to talk more with the First Nations Health Authority about what how we can help in terms of organizing testing to help you guys. So just reach out and we can talk about the techniques we use and whatnot.
Wonderful. Thank you very much.
Okay, I think we're already half an hour over.
I do too.
And
Okay.
people are trailing off.